Imagine three unstoppable cosmic monsters, each powerful enough to warp space and time itself, locked in an endless, unpredictable dance. Not just one, not two, but three supermassive black holes orbiting each other in a chaotic, high-speed struggle that defies everything we think we know about physics. This isn't just a sci-fi concept, this is real. A chaotic triple supermassive black hole system is one of the rarest, most extreme, and most mysterious phenomena in the universe. Scientists have barely begun to scratch the surface of what happens when three of the most powerful objects in existence get trapped in each other's gravitational grip. The rules of physics seem to break, time itself distorts, and the very fabric of reality bends in ways we can barely comprehend. But how do these systems form? What happens inside them? And could they hold secrets that could unlock deeper truths about the nature of the universe itself? But before we continue, subscribe to the channel so you don't miss out on any of these videos. To understand the madness of a chaotic triple supermassive black hole system, we first need to understand supermassive black holes themselves. These aren't just any black holes. These are the giants sitting at the centers of galaxies, millions to billions of times the mass of our Sun. They govern the behavior of entire galaxies, shaping their structure, affecting star formation, and even deciding their long-term fate. The idea of two of them interacting is already mind-blowing enough. Two incredibly dense, infinitely powerful objects, locked in a gravitational battle, spiraling toward an eventual merger that releases more energy than a trillion stars. But when you add a third one into the mix, the entire system becomes unpredictable. No stable orbits. No simple patterns. Just chaos. Triple supermassive black hole systems are so rare that only a handful have ever been detected, and even those are barely understood. When three black holes of such immense mass get close enough to each other, their gravitational forces begin to clash in ways that create extreme distortions in spacetime. Unlike binary systems, where two black holes eventually merge in a predictable way, a three-body system can become wildly unstable. The forces between them keep shifting, orbits get scrambled, and sometimes one of the black holes gets slingshot out of the system at mind-bending speeds, faster than entire galaxies can move. This kind of violent ejection could send a supermassive black hole hurtling through space, tearing through anything in its path. Scientists have already found evidence of rogue black holes moving at millions of miles per hour, possibly the result of these chaotic triple systems breaking apart. But what happens when all three stay together? That's where things get even stranger. The gravitational waves generated by such a system are some of the most extreme in the universe. These waves ripple through space and time itself, distorting everything they pass through. If we could observe a chaotic triple black hole system up close, it would be unlike anything else in the cosmos. Imagine stars being ripped apart, gas clouds being shredded and consumed, and bursts of energy more powerful than entire galaxies lighting up the darkness. Some of the brightest quasars we've ever seen might actually be powered by triple black hole systems, their combined energy fueling jets of radiation that can stretch for millions of light years. The real question is, how do these systems even form? Scientists believe that when galaxies collide, their central black holes eventually drift toward each other due to gravitational interactions. If two galaxies merge, their black holes will also merge. But if a third galaxy crashes into the mix before that happens, things become unpredictable. Three black holes competing for dominance in the same system create a situation so chaotic that predicting their movements becomes nearly impossible. Unlike binary systems, where we can calculate the eventual merger, a triple system operates under the rules of the three-body problem, a classic problem in physics that describes how three gravitational bodies interact in ways that can never be fully predicted. This means that a chaotic triple supermassive black hole system could remain unstable for millions of years. Orbits keep shifting, energy keeps being exchanged, and at any moment, one of the black holes could be ejected entirely. But what if all three eventually collide? If two black holes merging releases an enormous burst of gravitational waves, imagine what three merging at the same time would do. It would create a gravitational event so extreme that it would send ripples through the fabric of the cosmos, distorting space-time itself on a scale never seen before. Even stranger, some theories suggest that chaotic triple black hole systems might be a key to understanding some of the biggest mysteries in physics. Some scientists believe that these systems could create the conditions necessary to test extreme theories of gravity, even those that go beyond Einstein's general relativity. In fact, observing the gravitational waves from a chaotic triple system could help us detect hidden dimensions of the universe or even provide evidence for entirely new physics. And then there's the question of what happens inside these black holes. Since we can't directly see beyond the event horizon, all we can do is theorize. But some physicists suggest that if three black holes interact in just the right way, they might create conditions where information isn't completely lost but instead gets scrambled in a way that could one day be decoded. This ties into one of the biggest debates in modern physics, the information paradox. Could chaotic triple systems be the missing piece to solving it? Could they hold clues about what happens to matter and energy when it falls into a black hole? Could they even hint at the existence of wormholes or other unknown structures in space-time? The more we learn about these systems, the more questions arise. How many of them exist? How often do they form? Could there be one lurking in a distant part of our own universe, hidden from view but distorting space-time in ways we've yet to detect? And what happens when we finally develop the technology to observe them in detail? The deeper we go into the mystery of chaotic triple supermassive black hole systems, the more the universe seems to defy logic. These systems exist in a state of cosmic unpredictability, where every gravitational interaction is a battle of forces so immense that even light itself bends and distorts in their presence. But here's where things get even stranger. What if these chaotic interactions don't just shape galaxies but also act as hidden engines of cosmic evolution? What if, instead of being mere accidents of galactic collisions, triple black hole systems are actually a fundamental part of how the universe structures itself? Let's take a step back and consider the scale of these events. We're talking about objects millions or even billions of times the mass of our Sun, each one creating a gravitational pull so powerful that not even light can escape. When three of them end up in the same region of space, they don't just sit quietly. They pull, twist, accelerate, and sometimes even throw each other out of the system entirely. But in doing so, they also send shockwaves of energy rippling across the cosmos. Astronomers have long speculated that the formation of chaotic triple supermassive black hole systems could be directly linked to some of the most violent and extreme events in the universe. When two galaxies merge, their central black holes will eventually drift toward each other, and in most cases, they will spiral inward and merge. But if a third black hole gets introduced before the first two can merge, the entire process becomes unpredictable. The orbits of all three keep changing, energy gets exchanged in ways that can't be easily mapped, and at any moment, one of the black holes could be hurled away at mind-boggling speeds. This process, known as dynamical friction, is one of the main reasons why some supermassive black holes end up wandering through space alone. When a triple system becomes too unstable, it often leads to one black hole being ejected, while the remaining two settle into a more stable binary orbit. But here's where things take a fascinating turn. Some scientists believe that these ejected black holes could explain the existence of rogue supermassive black holes, giant objects moving through the universe at speeds so fast that they could travel between galaxies. If this is true, it means that every chaotic triple system that breaks apart could be sending black holes flying through the universe, shaping the structure of space in ways we're only beginning to understand. And then there's the question of gravitational waves. When two black holes merge, they create an enormous burst of gravitational waves, ripples in spacetime that travel across the universe. But what about a system with three? Could a chaotic triple system generate gravitational waves in a way we've never seen before? Scientists are already studying the possibility that triple black hole interactions could create bursts of gravitational waves that don't just happen once, but in a pattern, almost like cosmic drumbeats. This could mean that, instead of a single event, some galaxies could have repeating bursts of gravitational waves over millions of years, each one carrying information about the chaotic dance of these black holes. One of the biggest challenges in studying chaotic triple supermassive black hole systems is that they are incredibly difficult to detect. Most black holes are found by observing the way they affect nearby objects, whether it's the way stars move around them, the way they bend light, or the way they interact with gas and dust. But when three supermassive black holes are tangled together, their interactions become so complex that traditional methods struggle to capture what's really happening. Some scientists believe that the best way to find these systems is by looking for strange patterns in quasars, distant galaxies with extremely bright centers powered by supermassive black holes. If a quasar's brightness fluctuates in an unusual way, it could be a sign that not one, but three black holes are fighting for control at its core. And this leads us to one of the biggest mysteries of all: what happens when all three black holes finally collide? If two black holes merging releases an enormous burst of energy, then a triple merger could be one of the most violent events in the universe. The energy released in such an event could outshine entire galaxies, sending shockwaves of gravitational waves across the cosmos. Some theories even suggest that if the conditions are just right, such an event could distort spacetime in ways that create temporary wormholes, bridges through space and time that could theoretically connect distant parts of the universe. But here's an even bigger question: could chaotic triple supermassive black hole systems be more than just random cosmic accidents? Some physicists believe that these systems might be evidence of something deeper, something fundamental about the way the universe works. There are theories that suggest the universe itself may have emerged from a chaotic interaction of energy and gravity, much like what we see in these extreme systems. Could it be that the formation of galaxies, the structure of space, and even the expansion of the universe itself are somehow linked to the chaos of black holes interacting? Could these systems be the missing key to understanding the very nature of time and space? The more we study these extreme systems, the more they challenge our understanding of physics. Einstein's theory of general relativity describes how gravity works on large scales, and quantum mechanics explains how particles behave on the smallest scales. But when it comes to black holes, especially chaotic systems involving multiple black holes, our understanding begins to break down. Some scientists believe that studying chaotic triple supermassive black hole systems could provide the ultimate test for physics itself. If we can observe these systems closely, we might be able to detect deviations from Einstein's equations, small clues that could point us toward a deeper, more complete theory of gravity. There's also the question of time itself. Black holes warp time in extreme ways. The closer you get to a black hole, the slower time moves. If you could somehow survive near a supermassive black hole, you would experience time differently than someone farther away. But what happens when three black holes are pulling on each other in a chaotic system? Could they create pockets of warp time so extreme that they act as natural time machines? Could there be regions around these systems where time loops back on itself or slows down in unpredictable ways? Some physicists have speculated that chaotic black hole interactions could create regions of space where time behaves in ways that defy our current understanding. And then there's the biggest question of all: are we looking at these systems the wrong way? What if, instead of being rare cosmic anomalies, chaotic triple supermassive black hole systems are actually common, but we just don't have the technology to see them yet? Some astronomers believe that in the next few decades, as new telescopes and gravitational wave detectors become more advanced, we may discover that these systems are everywhere. If that's the case, then everything we thought we knew about galaxies, gravity, and black holes may need to be rewritten. The universe has a way of surprising us. Every time we think we've figured out its rules, we find something that breaks them. Chaotic triple supermassive black hole systems are one of the biggest puzzles we've ever encountered. Objects so massive, so powerful, and so unpredictable that they challenge everything we thought we understood about physics. But in their chaos, there may be answers. Answers about the nature of time, space, and reality itself. And as we continue to push the boundaries of science, one thing is clear: the deeper we look into the cosmos, the stranger and more mysterious it becomes. The deeper we dive into the mysteries of chaotic triple supermassive black hole systems, the more we realize how little we truly understand about the universe. These monstrous gravitational behemoths are not just anomalies. They may be fundamental components of cosmic evolution. If we could decipher the chaotic dance of three supermassive black holes, we might unlock secrets about galaxy formation, gravitational wave propagation, and even the very nature of spacetime itself. One of the most perplexing aspects of these systems is the way they alter the structure of the galaxies they reside in. When a single supermassive black hole sits at the heart of a galaxy, it dominates its surroundings, influencing star formation, gas distribution, and even the movement of entire clusters of stars. When two black holes merge, they send out immense bursts of energy, reshaping the galaxy in the process. But what happens when there are three? Instead of a predictable gravitational pull, the forces at play become erratic, leading to a turbulent environment where stars can be ejected at unimaginable speeds, entire sections of the galaxy can be torn apart, and even dark matter might be affected in ways we haven't yet observed. This unpredictability has led some astronomers to propose that chaotic triple supermassive black hole systems might be responsible for some of the strangest cosmic events we've recorded. Take, for example, the mysterious phenomenon of hypervelocity stars, stars that are moving so fast they are escaping the gravitational pull of their home galaxies. While we've long suspected that these stars were flung out by interactions with black holes, a triple system could provide the necessary chaos to accelerate a star to such extreme speeds that it becomes a rogue wanderer of intergalactic space. And then there's the matter of gravitational wave bursts. Since the first detection of gravitational waves in 2015, scientists have been on the lookout for unusual signals, patterns that don't fit the standard merger model of two black holes spiraling together and colliding. If a chaotic triple system exists, it could produce gravitational wave signals that are entirely different from anything we've seen before. Instead of a simple waveform that increases in frequency as two black holes merge, a triple system could create erratic, unpredictable signals, gravitational waves that fluctuate wildly before culminating in an explosive finale. Some researchers have even suggested that these systems might be detectable through a unique form of gravitational lensing. When light from a distant galaxy or quasar passes near a black hole, its path bends, creating a magnified or distorted image. But in a chaotic triple system, the effects of lensing could be far stranger. Light might be twisted in unpredictable ways, creating multiple, shifting images of the same object, or even distorting time itself, causing distant galaxies to appear as though they are flickering in and out of existence. If we can identify these bizarre lensing patterns, we might finally have a way to pinpoint chaotic triple supermassive black hole systems across the cosmos. But perhaps the most fascinating aspect of these systems is what they could reveal about the fundamental nature of black holes. Despite decades of study, black holes remain one of the greatest mysteries in physics. We still don't fully understand what happens inside them, how they interact with the fabric of spacetime, or even if our current theories of gravity are capable of describing their true nature. Some physicists believe that chaotic triple systems could be the key to testing the limits of Einstein's general relativity. If we could observe how three supermassive black holes warp spacetime while interacting with each other, we might uncover new physics, perhaps even clues to a deeper theory that unifies general relativity and quantum mechanics. There's also the question of dark matter. While we can't see dark matter directly, we know it exists because of its gravitational influence on galaxies. But what if chaotic triple supermassive black hole systems are capable of distorting or even interacting with dark matter in ways we haven't yet imagined? Some theories suggest that the extreme gravitational forces in these systems could temporarily compress dark matter, creating regions of intense density that might momentarily produce detectable effects. If true, these systems could serve as cosmic laboratories for studying one of the most elusive substances in the universe. And then there's the biggest mystery of all: what happens when all three black holes collide? A single black hole merger releases more energy than all the stars in a galaxy combined. But if three supermassive black holes were to collide in a single event, the explosion of energy could be unlike anything we've ever seen. Some scientists theorize that such a merger could send gravitational waves powerful enough to shake the very structure of the universe itself. Others believe that, under the right conditions, a triple merger might even momentarily tear a hole in spacetime, creating an event horizon so unstable that it could briefly expose the singularity within. But perhaps the most mind-bending possibility is that chaotic triple supermassive black hole systems might not just be influencing the universe. We might be seeing the remnants of something much older than we realize. There are theories that suggest black holes could have existed before the formation of galaxies, forming in the early moments of the universe's existence. If that's true, then chaotic triple systems might be relics of an even earlier cosmic era, remnants of a time when the universe was still young and structure was just beginning to take shape. The study of these extreme systems is still in its infancy, but one thing is clear: the more we learn, the more questions we uncover. Every chaotic interaction, every unpredictable ejection, every strange gravitational effect could hold the key to understanding not just black holes, but the very nature of space, time, and reality itself. And as our telescopes grow more powerful, as our gravitational wave detectors become more sensitive, we may finally begin to unravel the mysteries of these cosmic monsters. The universe is not a calm and orderly place. It is wild, unpredictable, and filled with forces beyond our comprehension. And nowhere is this chaos more evident than in the heart of a galaxy where three supermassive black holes are locked in an endless battle of gravity and destruction. We are only just beginning to understand what these systems are, how they form, and what they might be trying to tell us. But one thing is certain: when it comes to the deepest mysteries of the cosmos, chaotic triple supermassive black hole systems might just be the strangest and most important clue we have. The idea that three supermassive black holes could be locked in an eternal gravitational struggle is more than just a cosmic oddity. It's a glimpse into the raw, untamed forces that shape the universe. These chaotic systems push the limits of our understanding, stretching the very fabric of space-time, and challenging the way we perceive cosmic evolution. But the true enigma lies in the sheer unpredictability of these interactions. Unlike a binary black hole system, which follows a relatively stable orbital decay until merger, a trio of these monsters creates a system so unstable that even the best supercomputers struggle to model their movements accurately. In a typical triple system, two black holes might initially form a close binary, orbiting each other like a tightly wound dance, while the third one lingers further away. But this configuration is anything but stable. The third black hole can perturb the binary, causing unpredictable shifts in orbits, sudden accelerations, and even chaotic flips in momentum. Over time, one of the black holes may be ejected entirely, launched at an incredible velocity that could send it hurtling out of its host galaxy and into the lonely void of intergalactic space. These runaway black holes are a particularly fascinating consequence of triple systems. If a supermassive black hole is expelled from its home galaxy due to gravitational interactions, it could travel through space for billions of years, never merging with another galaxy, never forming new stars around it, just a wandering colossus, drifting endlessly. Some theories even suggest that we might one day detect these ejected black holes as they distort the light from distant background galaxies, revealing their presence through the subtle warping of spacetime. The chaotic nature of these systems also has implications for our understanding of time itself. Since black holes significantly warp the fabric of spacetime, a system with three supermassive black holes could create regions where time dilation effects are far more extreme than what we typically observe. If an object, like a star or a dense cloud of gas, were to pass through the complex gravitational field of such a system, it might experience time at an entirely different rate compared to the rest of the universe. In theory, chaotic triple systems could act as natural time distorters, creating cosmic regions where time flows irregularly due to the intense gravitational warping. The implications don't stop there. Some theorists speculate that if we could somehow observe or measure these extreme time distortions, it might provide clues about the nature of black hole singularities, those mysterious points of infinite density hidden beyond the event horizon. Could chaotic triple systems momentarily expose aspects of a singularity that are normally hidden from view? Could they reveal new insights into the interplay between quantum mechanics and gravity? These are questions that push at the very boundaries of modern physics. One of the biggest challenges in studying these chaotic triple systems is simply finding them. Most black holes are invisible unless they are actively consuming matter, which creates the brilliant, energetic disks we associate with quasars and active galactic nuclei. But if three supermassive black holes are interacting in a way that prevents steady accretion, they might be hiding in plain sight, blending into the cosmic background with only their gravitational influence hinting at their existence. To detect them, astronomers are looking for unusual signals, fluctuations in brightness that don't match the standard behavior of a single or binary black hole, or irregular gravitational wave patterns that suggest more than two massive bodies are interacting. Upcoming space telescopes and next-generation gravitational wave observatories might finally give us the tools to identify these elusive systems with certainty. There's also the possibility that chaotic triple supermassive black hole systems could be responsible for some of the strangest high-energy phenomena we've observed in deep space. Take, for example, the mysterious fast radio bursts, FRBs, brief, incredibly powerful flashes of radio waves that seem to come from all over the universe. While many theories exist to explain them, some scientists have proposed that the violent interactions within a chaotic triple system could generate such bursts. As black holes rapidly change positions and magnetic fields are violently twisted. Similarly, some of the most energetic quasars, bright, active galaxies that shine with the power of billions of suns, might be powered not by a single black hole, but by a chaotic trio. If three supermassive black holes are pulling at each other, their accretion disks could be torn apart and reformed multiple times, creating the erratic and unpredictable light curves we see in some of the most extreme quasars. And then there's the question of how common these systems really are. While we've only identified a handful of candidate triple supermassive black hole systems, there could be countless others lurking undetected across the universe. Some galaxies might even have hosted multiple triple systems over their lifetimes, as they merged with other galaxies and collected additional black holes in the process. If that's true, then chaotic triple systems might not be rare cosmic outliers. They might be fundamental to how galaxies grow and evolve. If we could truly map out and understand these chaotic systems, we might be able to predict the long-term fate of galaxies like our own Milky Way. Currently, we know that the Milky Way is on a collision course with the Andromeda Galaxy, set to merge in about 4.5 billion years. Each of these galaxies has a supermassive black hole at its core, and when they finally collide, their black holes will spiral toward each other and merge. But if a third black hole, perhaps from a smaller galaxy that gets caught up in the process, were to enter the mix, the situation could become far more unpredictable. Could our own galaxy one day host a chaotic triple system? And if so, what would that mean for the stars, planets, and life that call the Milky Way home? While we're still far from answering these questions definitively, one thing is certain: the universe is a far stranger, more chaotic place than we ever imagined. And somewhere out there, in the depths of space, three colossal black holes are locked in a gravitational struggle so intense, so unpredictable, that it might hold the key to some of the greatest mysteries of existence. The gravitational struggle between three supermassive black holes isn't just a cosmic ballet. It's an unpredictable battle where the rules of physics are stretched to their limits. Unlike binary systems, where two black holes eventually spiral inward and merge, a triple system never settles into stability. Instead, the interactions create erratic orbits, abrupt energy shifts, and occasional violent ejections that defy easy prediction. Even using the most advanced simulations, physicists struggle to map out the long-term future of these systems, as even minor differences in mass, velocity, or positioning can send the entire system down wildly different paths. One of the most fascinating aspects of these systems is the potential for repeated close encounters between black holes. When three supermassive black holes orbit each other in a chaotic dance, they don't always maintain a fixed hierarchy. Instead, the gravitational forces can cause sudden changes, where one black hole is momentarily slingshot away, only to come crashing back in a different configuration. These violent encounters can release enormous amounts of energy, generating some of the most powerful gravitational waves in the universe. Gravitational waves, first detected by LIGO in 2015, are ripples in space-time caused by massive objects accelerating and merging. In a chaotic triple system, gravitational waves are emitted not just during a final merger but throughout the entire lifespan of the system. Every sudden change in orbit, every momentary near collision, and every gravitational slingshot creates ripples that spread across the cosmos. These signals could be unlike anything we've ever detected, erratic, unpredictable, and more complex than the smooth waveforms produced by binary black hole mergers. Some astronomers believe that these chaotic systems could help solve a major cosmic mystery: why we haven't detected as many supermassive black hole mergers as expected. If triple systems are more common than we realize, it's possible that many black hole pairs never actually merge. Instead, the chaotic interactions might prevent the final end spiral, keeping the black holes in an endless game of gravitational tag. In some cases, a third black hole could even kick a merging pair apart, delaying the merger indefinitely. This could explain why we haven't observed as many supermassive black hole mergers in the gravitational wave data. Many of them might still be stuck in chaotic orbits, unable to reach the final stage. Another bizarre consequence of these interactions is the potential for extreme relativistic jets. When black holes consume matter, they often generate powerful beams of energy, called jets, that shoot out at nearly the speed of light. These jets are typically aligned with a black hole's spin axis, but in a chaotic triple system, things get complicated. As the black holes pull and twist each other, their spin axes can shift unpredictably, causing the jets to change direction in erratic ways. Some of the strangest radio signals we've observed from deep space, signals that seem to move, flicker, or suddenly vanish, could be the result of jets from chaotic triple systems constantly shifting and realigning. These unpredictable interactions might also help explain some of the largest and most energetic explosions ever recorded in the universe. While gamma-ray bursts and supernovae are often associated with massive star deaths, some theorists believe that chaotic black hole systems could create similar high-energy outbursts. If a black hole in a triple system suddenly changes its orbit and disrupts a surrounding accretion disk, it could generate a massive explosion, releasing energy on a scale rivaling the biggest cosmic events. These outbursts could appear as transient signals, brief but immensely powerful flashes of light and radiation that we struggle to categorize. Despite all these possibilities, the biggest question remains: how many of these systems actually exist? Finding them isn't easy. Since black holes don't emit light on their own, astronomers have to rely on indirect methods, like watching how they influence surrounding stars, gas, and light. In some cases, triple systems have been suspected because of unusual patterns in quasar flickering or irregular gravitational lensing effects. However, the true number of chaotic triple systems in the universe could be far greater than we currently estimate. Some researchers have proposed that the most active galactic centers, those that seem to flicker unpredictably, show unusual X-ray signatures, or emit strange radio bursts, might actually be hiding triple systems. If this is true, then our understanding of black hole growth and galaxy evolution might need to be reconsidered. Instead of assuming that most galaxies host a single supermassive black hole at their core, we might have to accept that chaotic multi-black hole interactions are a fundamental part of the cosmic story. Another mind-bending question is whether these systems could exist not just in the present-day universe, but in its very early stages. The first galaxies formed just a few 100 million years after the Big Bang, and they likely underwent violent mergers as they grew. If triple black hole systems were common back then, they might have played a key role in shaping the first massive galaxies. These early chaotic interactions could have influenced how galaxies grew, how stars formed, and even how the distribution of matter was shaped on a cosmic scale. Even more extreme scenarios suggest that chaotic triple systems might not be limited to supermassive black holes. Some theories propose that there could be nested systems, where multiple tiers of black holes interact across different scales. Imagine a system where not just three, but several black holes orbit each other in a complex hierarchy, some at the supermassive level, others at the stellar mass level. These multi-tiered interactions could create some of the most bizarre and complex gravitational environments in the universe. As we push forward with new telescopes, more advanced simulations, and better gravitational wave detectors, we may finally begin to unlock the full secrets of these chaotic systems. If we can understand them, we might gain insights not just into black holes themselves, but into the fundamental forces that govern space-time. Could chaotic triple systems be a natural laboratory for testing ideas about quantum gravity? Could they help us unravel the mysteries of singularities and the limits of general relativity? These are questions that may define the next era of astrophysics. One thing is certain: Somewhere, right now, in the depths of space, 3 supermassive black holes are locked in a gravitational struggle so complex, so powerful, and so unpredictable that it defies comprehension. Their movements, dictated by nothing but the raw forces of gravity, are rewriting the cosmic landscape with every passing moment. And as we continue to peer deeper into the universe, we may one day witness one of these colossal systems in action, revealing secrets that could change everything we think we know about the nature of reality itself. The nature of chaotic triple supermassive black hole systems challenges some of our most fundamental assumptions about how gravity operates on the largest scales. In a binary system, there's a clear path toward a merger. 2 black holes gradually lose energy through gravitational waves until they spiral into each other. But in a triple system, the constant gravitational disruptions can keep the black holes in a state of perpetual motion, delaying or even preventing the final merger. This chaotic interplay raises profound questions about the fate of these systems. One possibility is that they eventually stabilize, with 2 black holes forming a tighter binary while the third one is ejected into intergalactic space. This scenario, known as a gravitational slingshot, could help explain the existence of rogue supermassive black holes, colossal objects drifting through the void without a galaxy to anchor them. If a supermassive black hole is violently flung out of a chaotic system, it could travel for billions of years without ever being recaptured. These rogue black holes might be some of the most elusive objects in the universe, nearly impossible to detect unless they pass through a dense gas cloud or collide with another object. But not all triple systems end with an ejection. In some cases, the interactions can lead to an accelerated merger process. If one black hole loses enough energy through gravitational wave emissions while another gains a boost from a close encounter, the system could rapidly collapse into a single, even more massive black hole. Such a merger would release an extraordinary burst of gravitational waves, far more complex than the signals we've observed from binary black hole mergers. If we could detect one of these chaotic mergers, it would provide an entirely new way to study how black holes interact. Recent discoveries suggest that some of the brightest and most energetic events in the universe may be linked to chaotic triple systems. One candidate is OJ287, a system that appears to have at least 2 supermassive black holes orbiting each other in an unpredictable pattern. The periodic flashes of light from OJ287 suggest that a third, hidden black hole might be influencing the system, creating irregular bursts of activity. If confirmed, this would be one of the first direct pieces of evidence for a chaotic triple supermassive black hole system in action. The discovery of more systems like OJ287 could reshape our understanding of how galaxies evolve. Traditionally, astronomers have assumed that most galaxies have a single supermassive black hole at their center. But if chaotic triple systems are more common than we thought, it could mean that many galaxies have experienced multiple black hole interactions throughout their history. Some of the strange, flickering quasars we observe could actually be signs of chaotic triple systems, where black holes are constantly pulling and distorting each other's accretion disks. And then there's the question of what happens when a chaotic triple system exists inside a dense galactic environment. In the heart of a galaxy cluster, where hundreds or even thousands of galaxies interact, black hole mergers could become even more chaotic. Instead of just 3 black holes, there could be a whole chain of gravitational interactions, leading to the formation of massive black hole conglomerates. These superclusters of black holes could create some of the most extreme environments in the universe, warping spacetime in ways that we can barely begin to understand. But perhaps the most exciting possibility is that chaotic triple systems could offer new insights into the nature of gravity itself. Our current understanding of gravity is based on Einstein's general relativity, which describes how massive objects warp spacetime. However, when 3 supermassive black holes interact chaotically, their gravitational forces push the limits of our equations, creating situations where even our best models struggle to predict what will happen next. These systems could be the perfect laboratories for testing alternative theories of gravity, including ideas that attempt to unify general relativity with quantum mechanics. Some physicists speculate that chaotic triple systems might even reveal hidden aspects of dark matter and dark energy. If black holes are surrounded by halos of dark matter, their chaotic interactions could create distortions in the surrounding dark matter field, leading to subtle but detectable effects. By studying how triple systems evolve over time, we might be able to gain indirect evidence about the nature of dark matter, something that has eluded scientists for decades. Even more speculative is the idea that chaotic triple black hole systems could provide clues about extra dimensions. Some theories suggest that gravity might leak into hidden dimensions of space, and the extreme gravitational interactions in these systems could be a way to test for these hidden realities. If we detect anomalies in the gravitational waves emitted by these systems, something that can't be explained by standard physics, it could be a sign that our understanding of spacetime is incomplete. As we continue to refine our ability to observe the universe, the study of chaotic triple black hole systems is poised to become one of the most exciting frontiers in astrophysics. The next generation of telescopes, including the Extremely Large Telescope, (ELT), and the James Webb Space Telescope, JWST, may help us identify more of these systems by observing their effects on surrounding gas and stars. At the same time, advancements in gravitational wave detection, such as the proposed Laser Interferometer Space Antenna, LISA, could allow us to hear the gravitational waves emitted by these systems in unprecedented detail. If we can unlock the mysteries of chaotic triple systems, we may be able to answer some of the biggest questions in cosmology. How do black holes grow? What happens when gravity reaches its limits? And could the behavior of these systems hint at physics beyond what we currently understand? One thing is certain, right now, somewhere in the universe, 3 supermassive black holes are engaged in a cosmic dance so chaotic, so powerful, and so unpredictable that it defies the imagination. Their interactions shape the fabric of space-time, sending ripples across the cosmos. And as we continue to explore the depths of the universe, we may one day witness one of these systems in action, revealing secrets that could change everything we know about the nature of reality itself. Chaotic triple supermassive black hole systems are some of the most unpredictable and powerful phenomena in the universe. Their gravitational interactions create a cosmic battleground where the very fabric of space-time is stretched, twisted, and sometimes torn apart in ways we barely understand. The sheer complexity of these systems challenges everything we think we know about how black holes evolve, how galaxies form, and even how gravity itself works. One of the most intriguing aspects of these chaotic systems is the possibility that they could lead to the formation of what some astronomers call staggered mergers. Unlike binary black hole mergers, where 2 black holes gradually spiral into each other in a predictable way, triple systems can create situations where 2 black holes merge first, forming a new, even more massive black hole, before the third one eventually collides with it. This staggered process could produce some of the most extreme gravitational wave signals ever detected, signals so unique that they could help us refine our understanding of black hole physics. But what happens in the moments leading up to these mergers? The gravitational forces in a chaotic triple system don't just affect the black holes themselves. They also influence everything around them. The accretion disks, massive swirling clouds of superheated gas and dust that feed the black holes, can be violently disturbed by the constant shifting of gravitational forces. In some cases, these disturbances can trigger massive flares of energy, as material gets slingshot away at nearly the speed of light. These energy outbursts could be some of the brightest explosions in the universe, potentially even explaining some of the mysterious high-energy cosmic events we've detected but have yet to fully understand. Even more fascinating is the idea that chaotic triple systems could create conditions that momentarily break the laws of physics as we understand them. When 3 supermassive black holes interact in an extreme gravitational environment, they might create what's known as a space-time anomaly, a region where the effects of gravity become so extreme that they defy normal calculations. Some physicists have even speculated that these anomalies could lead to brief windows where exotic physics comes into play, potentially creating conditions similar to those just after the Big Bang. This raises an even more mind-bending question: could chaotic triple systems be responsible for some of the strangest cosmic events we've ever observed? For example, there are unexplained bursts of gamma-ray energy that seem to come from nowhere, lasting only fractions of a second but carrying more energy than entire galaxies. Some theories suggest that these bursts could be linked to the complex interactions of three black holes locked in a chaotic gravitational struggle. If true, this would mean that some of the most mysterious and powerful phenomena in the universe are being fueled by the hidden chaos of triple black hole systems. But perhaps the most shocking possibility is that some of these systems might not just be chaotic. They might be creating conditions that are fundamentally different from anything we've ever seen before. Some physicists believe that if three black holes interact in just the right way, they could create a feedback loop that bends spacetime to such an extreme degree that it could form what's known as a gravitational echo. This would be a phenomenon where the gravitational waves emitted by the system start to interfere with themselves, creating a repeating pattern that could, in theory, last for billions of years. If we could detect one of these gravitational echoes, it would be a groundbreaking discovery, one that could challenge our entire understanding of how black holes work. It might even hint at new physics that we've never considered before, including the possibility that spacetime itself is more flexible than we currently believe. Some even suggest that these echoes could be evidence of hidden dimensions, where gravity behaves differently than it does in the three-dimensional space we're familiar with. As we continue to study chaotic triple supermassive black hole systems, we are also uncovering new insights about what happens when they finally merge. The process is not always straightforward. Some mergers might be slow and gradual, while others could be sudden and violent, releasing a burst of energy that could be felt across the entire universe. These final mergers could be among the most energetic events in cosmic history, outshining entire galaxies for brief moments. One of the biggest mysteries surrounding these systems is what happens in the aftermath of a chaotic triple black hole merger. The resulting black hole, now even more massive than before, could have properties that are different from any black hole we've studied. Some scientists believe that these post-merger black holes might spin at near maximum speeds, warping spacetime around them in ways that could create temporary distortions, almost like ripples in reality itself. And then there's the possibility that chaotic triple systems could be tied to the origins of supermassive black holes themselves. One of the greatest unsolved mysteries in astrophysics is how supermassive black holes, some of which are billions of times more massive than the Sun, formed so early in the universe. Some researchers believe that chaotic interactions between multiple black holes in the early universe could have accelerated their growth, helping them reach enormous sizes in a relatively short period of time. This theory suggests that the first supermassive black holes may have been born not from single collapsed stars, but from the violent, chaotic mergers of smaller black holes in dense, early galaxies. If true, this would mean that chaotic triple systems played a crucial role in shaping the structure of the universe as we see it today. With every new discovery, the mystery of chaotic triple supermassive black hole systems only deepens. We are only beginning to scratch the surface of what these cosmic monsters are capable of, and yet they may hold some of the biggest answers to the most fundamental questions we have about the universe. What happens when gravity is pushed to its limits? How do black holes shape the galaxies around them? And could these chaotic interactions be the key to unlocking entirely new laws of physics? One thing is certain, somewhere out there, in the depths of the cosmos, there are black holes locked in an eternal battle. A chaotic, unpredictable struggle that could continue for billions of years before finally reaching its conclusion. And when that conclusion comes, the universe itself might shake from the force of their final, ultimate merger. Chaotic triple supermassive black hole systems are not just fascinating because of their unpredictability, but also because they reveal deeper truths about how the universe works. The gravitational dance of three immense objects warping spacetime around them creates an environment so extreme that it may hold the key to understanding concepts beyond our current physics. One of the most perplexing possibilities is that these systems might be capable of momentarily breaking the speed limit of information travel. While general relativity states that nothing can exceed the speed of light, some theories suggest that in the highly curved spacetime near multiple interacting black holes, there could be scenarios where gravitational information moves in ways we don't yet comprehend. This raises an astonishing possibility. Could chaotic triple supermassive black holes be the only places in the universe where information travels differently than we expect? Some researchers have proposed that extreme warping of spacetime in these systems might create what is known as a causal loop. A situation where information sent out from one black hole could, due to the effects of intense gravitational distortion, arrive somewhere else before it was even sent. If this is true, it would challenge everything we believe about cause and effect, and it could even have implications for understanding whether time itself is truly linear. The extreme gravitational distortions of triple systems could also impact nearby galaxies in unexpected ways. When three black holes interact chaotically, their immense combined gravitational pull can send shockwaves through the surrounding cosmic environment. Some simulations suggest that chaotic triple systems might be responsible for ejecting entire stars from galaxies at speeds fast enough to send them hurtling into intergalactic space. These so-called hypervelocity stars, some of which have already been observed, could be the remnants of these violent black hole interactions. But if triple supermassive black holes can fling stars into deep space, what about planets? Could entire planetary systems be torn away from their home galaxies and cast adrift in the void? The answer is yes, and if this happens, it raises another tantalizing question: could rogue planets ejected from chaotic black hole systems still harbor life? If so, these drifting worlds, separated from any star, would rely on their own internal heat to sustain life deep beneath their frozen surfaces. This means that triple black hole systems, despite their chaotic destruction, might play a role in creating planets that could sustain life under extreme conditions. Another major mystery tied to these chaotic systems is their connection to gravitational waves. When black holes merge, they send ripples through space-time, but in a triple system, those waves could be much more complex than anything we've observed so far. Unlike the simple up and down patterns of traditional black hole mergers, chaotic triple systems might create gravitational waves with patterns so intricate that they appear to be scrambled or layered on top of each other. These chaotic waveforms could hold the secrets to understanding the deepest aspects of black hole physics. One of the strangest ideas in theoretical physics is that the chaotic interactions of black holes might even create momentary shortcuts through spacetime, what we commonly call wormholes. While no wormhole has ever been observed, some physicists believe that the extreme distortions of spacetime around chaotic triple systems could, in theory, momentarily create conditions where spacetime folds back on itself. If this is true, it could be the closest thing to natural time travel that exists in the universe. And then there's the possibility that some chaotic triple supermassive black hole systems might be entirely invisible to us. If these systems exist in regions of space where light cannot escape due to extreme gravitational warping, then there could be entire clusters of black holes hidden in the dark, silently influencing the galaxies around them without us even knowing they exist. This could explain some of the anomalies we've observed in the rotation of galaxies, mysterious effects that some scientists currently attribute to dark matter. The more we study chaotic triple supermassive black hole systems, the more we realize that they might be far more common than we once thought. Some estimates suggest that a significant percentage of massive galaxies contain not just one or two, but three or more supermassive black holes orbiting in a gravitational dance of destruction. If this is the case, then these chaotic interactions could be one of the most important mechanisms shaping the evolution of the universe itself. The implications of chaotic triple supermassive black hole systems stretch far beyond just their gravitational interactions. They could be among the most extreme environments in the universe, where physics itself begins to behave in ways we do not fully understand. One of the biggest unanswered questions in astrophysics is whether gravity, at its most intense, could interact with the quantum world in ways that defy our current theories. If there is any place in the cosmos where such an interaction could be observed, it would likely be within these chaotic systems, where three immense singularities bend spacetime to its absolute limits. At the heart of this mystery is a fundamental problem. Einstein's general relativity and quantum mechanics do not agree with each other. General relativity works beautifully on large scales, explaining how gravity shapes galaxies, bends light, and warps time. But at the microscopic level, in the world of atoms and subatomic particles, quantum mechanics takes over, operating with a completely different set of rules. Normally, these two realms do not interact in any noticeable way. But near a chaotic triple black hole system, where spacetime itself is in constant, violent flux, the two theories might be forced to collide. Some physicists believe that if we could observe these interactions closely enough, we might uncover evidence of a long theorized but never observed phenomenon: quantum gravity. Quantum gravity is the missing link between the two great pillars of physics. It is the theory that would explain how gravity works at the tiniest scales and how space-time itself emerges from quantum interactions. If chaotic triple supermassive black hole systems are the best laboratories for testing these ideas, then studying them might lead to the most profound breakthrough in our understanding of reality itself. Another bizarre possibility linked to these systems is the idea that they might serve as natural particle accelerators. Normally, we build massive machines like the Large Hadron Collider to smash particles together at nearly the speed of light. But some scientists believe that the extreme conditions near chaotic triple black hole systems could naturally accelerate particles to energies beyond anything we can achieve on Earth. If this is true, it raises an astonishing possibility. Could these systems be producing particles that we have never seen before? Particles that could hold the key to understanding dark matter? Dark matter remains one of the biggest unsolved mysteries in physics. We know that something is exerting gravitational influence across the universe, but we cannot see it, and we do not know what it is made of. Some theories suggest that dark matter is composed of unknown particles that do not interact with light. If chaotic triple black hole systems can naturally accelerate particles to extreme speeds, they might also be capable of producing exotic forms of matter. If we could detect these particles, they might finally reveal the true nature of dark matter. But what if chaotic triple black hole systems are not just affecting the physical universe? What if they are also altering time itself? One of the strangest effects of extreme gravity is time dilation, the slowing down of time in the presence of a massive gravitational field. In a triple system, where space-time is constantly being stretched, twisted, and deformed, time might behave in ways that defy our usual understanding. Could there be regions within these systems where time loops back on itself? Could there be places where time moves faster or slower than expected? If so, these systems might be the closest thing to natural time machines that exist in the universe. There is also the question of what happens when one of these systems collapses. Over time, triple black hole interactions are unstable, meaning that sooner or later, two of the black holes are likely to merge, while the third is either ejected or absorbed. When this happens, the merger releases a tremendous burst of gravitational waves, ripples in spacetime that can be detected across the universe. But what happens to the third black hole? If it is ejected at high enough speeds, it could become a rogue supermassive black hole, drifting through intergalactic space. Some scientists believe that these wandering black holes might already exist, moving silently through the cosmos, consuming everything in their path. And then there is the biggest question of all: could chaotic triple supermassive black hole systems be hiding something even stranger than we can imagine? Some theoretical physicists have proposed that inside these systems, deep within the tangled web of distorted spacetime, there could be unknown structures that defy our understanding. Could there be stable regions within these chaotic systems where entirely new forms of matter or energy exist? Could there be natural cosmic phenomena that we have never even conceived of? The deeper we look into chaotic triple black hole systems, the more we realize that they might be among the most important objects in the universe. They challenge our understanding of physics, push the limits of space-time, and could hold the answers to some of the biggest mysteries in science. And yet, they remain almost entirely unexplored. We have only detected a handful of potential triple systems, and we are only beginning to understand what they might be capable of. In the coming years, new telescopes and gravitational wave detectors might finally allow us to study these systems in detail. When that happens, we might be on the verge of discoveries that will change our understanding of the universe forever. But until then, these chaotic systems remain one of the greatest cosmic mysteries, vast, powerful, and hidden in the darkness of deep space. Chaotic triple supermassive black hole systems are like cosmic pressure cookers, where gravity, motion, and extreme energy interact in ways we can barely comprehend. If a single black hole already defies our understanding, imagine the sheer unpredictability of three of them locked in a gravitational tug-of-war, constantly distorting the fabric of reality around them. These are not just distant astronomical curiosities. They could be the key to unlocking some of the biggest mysteries in physics, from the nature of time itself to the elusive dark matter that makes up most of the universe. One of the most fascinating aspects of these chaotic systems is their sheer instability. Unlike binary black holes, which settle into relatively predictable orbits, triple systems are inherently chaotic. Over time, their interactions create gravitational slingshots, where one of the black holes can suddenly be ejected at nearly the speed of light. This process, known as a three-body ejection, has been observed in star systems, but in the case of supermassive black holes, the consequences are on a whole different scale. Imagine a rogue supermassive black hole, millions or even billions of times the mass of our Sun, hurtling through intergalactic space, tearing apart anything in its path. Scientists believe that some of these ejected black holes might be completely invisible, roaming the cosmos undetected. But if they happen to pass through a region dense with gas or stars, they could create some of the most energetic events in the universe. As they consume matter, they would form temporary accretion disks, swirling, superheated rings of gas spiraling toward their event horizon. This would produce powerful X-ray and radio emissions, potentially revealing their presence. However, because these black holes are not bound to any galaxy, they would be harder to track than those at the centers of galaxies. Another mind-bending possibility is that chaotic triple black hole systems might be influencing the expansion of the universe itself. Astronomers have long struggled to explain certain anomalies in cosmic expansion rates, which seem to vary depending on how they are measured. One theory suggests that gravitational interactions within extreme systems, like triple black hole systems, could be creating localized distortions in spacetime that affect our measurements. If true, this could mean that some of our assumptions about how the universe expands need to be revised. Then there is the possibility that these systems could be influencing dark energy, the mysterious force driving the accelerated expansion of the universe. Some theories propose that dark energy might not be a uniform force but could instead be generated by certain cosmic structures. If chaotic triple black hole systems can create intense distortions in spacetime, could they also be responsible for producing localized pockets of dark energy? If so, studying them might bring us closer to understanding the true nature of the force that controls the fate of the cosmos. But perhaps the most bizarre question of all is whether chaotic triple black hole systems could be connected to alternate dimensions or hidden aspects of reality. Some physicists have speculated that extreme gravitational environments, where spacetime is warped beyond recognition, might act as natural gateways to higher dimensions. If extra dimensions exist, as some versions of string theory suggest, then the immense warping of spacetime within these chaotic systems might provide a way to detect them. Could there be regions within these systems where the laws of physics break down entirely? Could they create natural wormholes, tunnels through spacetime that connect distant parts of the universe, or even different universes? These ideas remain speculative, but the fact remains, chaotic triple supermassive black hole systems represent some of the most extreme environments in the cosmos, where physics is pushed to its absolute limits. As our observational technology improves, we might finally be able to study them in more detail, unlocking new secrets about gravity, quantum mechanics, and the very structure of the universe itself. Until then, these cosmic titans remain some of the greatest mysteries in astronomy, waiting for us to uncover their secrets. The deeper we dive into the mysteries of chaotic triple supermassive black hole systems, the more we realize how little we truly understand about them. These immense, unpredictable cosmic engines represent the absolute limits of known physics, where space, time, and gravity become so distorted that even our best theories struggle to make sense of what is happening. They challenge everything we think we know about the universe, from the way galaxies evolve to the very nature of time itself. But the biggest question of all remains, could they be hiding something even stranger than we can imagine? One of the most intriguing possibilities is that these systems might be responsible for some of the unexplained cosmic phenomena we observe. For example, astronomers have detected mysterious flashes of energy coming from deep space, high-energy bursts that don't fit into any known category. Some of these could be linked to chaotic triple black hole systems, where sudden gravitational interactions cause an unexpected release of energy. If two black holes in the system suddenly merge while the third remains separate, It could create an enormous burst of gravitational waves, shaking space-time itself and sending ripples across the universe. But what if there's more to it than that? Some physicists have suggested that chaotic triple black hole systems could be capable of producing exotic forms of radiation, unlike anything we've seen before. The extreme warping of space-time might create conditions where unknown particles are generated, potentially explaining some of the strange cosmic signals we've detected. If these systems can naturally accelerate particles to nearly the speed of light, they might be producing ultra-high-energy cosmic rays, particles so powerful that they challenge our understanding of physics. Could they be creating entirely new forms of matter? Could they be revealing hidden forces that have so far remained undetected? Then there's the question of what happens inside the event horizons of these black holes. In a single black hole, anything that crosses the event horizon is lost forever, at least according to our current understanding. But in a triple system, where immense gravitational distortions are constantly shifting the fabric of space-time, the rules might be different. Could these systems allow for strange loopholes in physics? Could there be regions within them where information is not lost but instead preserved in some unknown way? Some theories suggest that black holes might not be the ultimate dead ends we assume them to be, but instead gateways to other parts of the universe, or even other realities. One of the most mind-bending ideas in modern physics is the holographic principle, which suggests that the entire universe might be like a hologram, with information stored on a vast cosmic boundary. If this is true, then chaotic triple black hole systems, with their extreme warping of space-time, might be places where this principle becomes most apparent. Could these systems hold the key to understanding the true nature of reality? Could they reveal that what we perceive as three-dimensional space is actually just a projection of something deeper? Another strange possibility is that chaotic triple black hole systems might be influencing the structure of the universe on a much larger scale than we realize. If enough of these systems exist, their gravitational interactions could be shaping the cosmic web, the vast, interconnected structure of galaxies and dark matter that spans the universe. Could they be playing a role in how galaxies cluster together? Could they be affecting the way dark matter behaves? If so, they might be far more important to the overall structure of the cosmos than we currently believe. And then there's the question of time. We know that strong gravitational fields can slow down time, but in a system where gravity is constantly shifting and twisting in unpredictable ways, what does that mean for the flow of time itself? Could chaotic triple black hole systems create pockets of time that move differently from the rest of the universe? Could they be natural time dilation zones, where events unfold at different rates depending on where you are? If so, could they help us understand one of the deepest mysteries of all, whether time is truly linear or if it can be bent, stretched, or even reversed under the right conditions? As we continue to study these chaotic systems, one thing becomes clear: they are among the most extreme and fascinating objects in the universe. They challenge our understanding of physics, they may be responsible for some of the strangest cosmic phenomena we've observed, and they could hold the answers to questions we haven't even thought to ask yet. With the next generation of telescopes and gravitational wave detectors, we may finally start to uncover their secrets. But until then, they remain one of the greatest mysteries in all of space, massive, powerful, and beyond our current comprehension. Chaotic triple supermassive black hole systems are among the most violent and enigmatic structures in the universe, warping spacetime to such an extreme degree that even the most advanced physics models struggle to predict their behavior. Unlike binary black holes, which tend to form stable orbits before eventually merging, three supermassive black holes create an environment of perpetual instability. Their gravitational interactions are so unpredictable that any attempt to simulate them inevitably leads to bizarre, seemingly random outcomes. This unpredictability arises from what physicists call the three-body problem, a fundamental challenge in celestial mechanics. In a system with only two objects, their mutual gravitational attraction follows clear and calculable paths, allowing us to predict their future positions with a high degree of accuracy. But introduce a third massive object, and everything changes. Small differences in their starting conditions can lead to dramatically different results, making long-term predictions nearly impossible. The same principle applies on a cosmic scale when three supermassive black holes are locked in a gravitational dance, constantly pulling and pushing each other in ways that defy conventional expectations. At any moment, one of the black holes could be hurled into intergalactic space, ejected at nearly the speed of light in a process known as gravitational recall. These ejected black holes, known as rogue supermassive black holes, could be wandering the universe completely undetected, leaving behind their former galaxies and drifting through the cosmic void. The existence of these rogue black holes presents an unsettling possibility. What if one of them is heading toward our galaxy? While the chances are slim given the vast distances between galaxies, the potential consequences of such an encounter would be beyond catastrophic. A supermassive black hole moving through space at relativistic speeds would be an unstoppable force, warping and distorting everything in its path. If it were to pass through a dense galactic cluster, it could trigger extreme gravitational disruptions, ripping apart entire solar systems and altering the orbits of countless stars. Even if it never directly interacted with another celestial body, its immense gravitational pull could send shockwaves through space, bending light and twisting the very fabric of reality in ways we can scarcely imagine. These rogue black holes could also be responsible for some of the most energetic cosmic events we've ever observed, such as unexplained bursts of high-energy radiation or extreme gravitational waves that shake the universe itself. If a rogue supermassive black hole were to collide with another, the resulting merger would release an unfathomable amount of energy, potentially outshining entire galaxies for brief periods of time. But the mysteries of chaotic triple black hole systems go even deeper. One of the most fascinating possibilities is that these systems might be natural laboratories for testing the limits of general relativity and quantum mechanics. Einstein's theory of general relativity, which describes gravity as the curvature of space-time, has been remarkably successful at explaining the behavior of massive objects like black holes. However, it breaks down at the singularity, the infinitely dense core of a black hole where the laws of physics as we know them cease to function. On the other hand, quantum mechanics, which governs the behavior of particles at the smallest scales, suggests that information cannot simply vanish from the universe. This creates a paradox when applied to black holes, which seem to destroy anything that falls into them. The problem is even more complicated in a chaotic triple black hole system, where extreme gravitational forces constantly shift and reshape space-time itself. Could these systems be revealing cracks in our understanding of the universe? Could they be pointing us toward a deeper, more fundamental theory of physics that unites relativity and quantum mechanics into a single framework? Some physicists have speculated that chaotic triple black hole systems might be capable of producing strange phenomena that challenge our perceptions of reality. One particularly wild idea is that they could create temporary distortions in the flow of time itself. We already know that strong gravitational fields slow down time relative to weaker ones, a phenomenon confirmed by experiments involving atomic clocks placed at different altitudes on Earth. In the extreme environment of a chaotic triple black hole system, where gravity is constantly shifting in unpredictable ways, time might behave even more strangely. There could be regions where time is stretched to near infinity, where a single second from the perspective of an outside observer could feel like millions of years for anything caught within the system's gravitational grip. This raises an even more bizarre question: could chaotic triple black hole systems act as natural time machines? While true time travel remains a subject of science fiction, some theories suggest that closed time-like curves, loops in spacetime where events can repeat themselves, might be possible under extreme gravitational conditions. If such loops exist within these systems, could they allow for information to travel backward in time? Could they explain some of the strange, unexplained cosmic signals that astronomers have detected, where bursts of energy seem to repeat without a clear source? Beyond time distortions, there is also the possibility that chaotic triple black hole systems could be acting as natural gateways to other parts of the universe, or even other universes entirely. Some versions of string theory propose the existence of extra dimensions beyond the three spatial dimensions and one time dimension that we experience. These extra dimensions could be curled up at incredibly small scales, hidden from our direct observation but still influencing the behavior of gravity on a fundamental level. If this is true, then the extreme gravitational conditions inside a chaotic triple black hole system might be capable of warping spacetime so intensely that they create pathways into these hidden dimensions. This idea is somewhat related to the concept of a wormhole, a hypothetical tunnel through spacetime that connects two distant points in the universe. While wormholes remain purely theoretical, chaotic triple black hole systems might provide the conditions necessary for their formation. If such pathways exist, could they be used for interstellar, or even intergalactic, travel? Could they explain some of the anomalies we've detected in deep space, where objects appear to shift positions in ways that defy conventional physics? The potential implications of these ideas are staggering. If chaotic triple black hole systems can create distortions in spacetime, influence the structure of the universe, or even provide clues about the nature of dark matter and dark energy, then they are far more than just cosmic oddities. They are key to understanding the deepest mysteries of existence itself. And yet, despite their significance, we still know so little about them. Part of the reason is that they are incredibly difficult to detect. Unlike single or binary black holes, which can be identified by their effects on nearby stars or their emissions of radiation, chaotic triple black hole systems are often hidden in the densest regions of galaxies, shrouded in vast clouds of gas and dust. Even when we do detect them, their unpredictable nature makes them hard to study over long periods of time. With current observational technology, we can only catch brief glimpses of their chaotic interactions before they shift into entirely new configurations, rendering our previous calculations useless. But that may soon change. With the next generation of space telescopes, such as the James Webb Space Telescope and future gravitational wave detectors, we may finally be able to observe these systems in unprecedented detail. If we can track their movements over extended periods, we may be able to develop new models that predict their behavior more accurately. More importantly, studying these systems could lead to groundbreaking discoveries that challenge our entire understanding of the universe. Could they be the missing link between classical physics and quantum mechanics? Could they hold the key to understanding dark energy, the mysterious force driving the accelerated expansion of the cosmos? Could they provide the first real evidence that our universe is just one of many, connected by hidden pathways that we have yet to uncover? For now, chaotic triple supermassive black hole systems remain one of the greatest unsolved mysteries of space. They are cosmic titans engaged in an eternal dance, their gravitational interactions shaping the evolution of galaxies and warping spacetime in ways we can barely comprehend. But as our technology improves and our understanding of the universe deepens, we may one day unlock their secrets, and in doing so, we may finally come closer to answering some of the biggest questions in science. Until then, these chaotic giants remain out there in the depths of space, waiting for us to uncover the truth hidden within their gravitational embrace. The chaotic nature of triple supermassive black hole systems raises profound questions about the very fabric of reality. When three black holes of immense mass interact, their gravitational forces constantly shift, creating an environment where space itself becomes an unpredictable battlefield of immense distortions. Unlike stable binary systems, which tend to follow somewhat predictable orbits until they merge, these trios are in a perpetual state of flux, with one black hole often being ejected from the system after an extended period of complex gravitational interactions. This violent expulsion sends the third black hole hurtling through the universe at speeds reaching a significant fraction of the speed of light, becoming a rogue black hole that drifts aimlessly through the cosmic void. The implications of these rogue black holes are staggering. Some astrophysicists believe that there could be hundreds, or even thousands, of these wandering behemoths scattered throughout the universe, completely invisible to traditional telescopes. Since black holes do not emit light on their own, they remain undetectable unless they interact with matter, such as by consuming a passing star or disturbing the structure of a galaxy. This means that there could be a rogue supermassive black hole moving through intergalactic space right now, completely unnoticed, unless it happens to pass through a region dense enough with gas or dust to reveal its presence. If such a black hole were to enter a populated galaxy, the consequences would be devastating. Even without directly colliding with stars or planets, its sheer gravitational pull would be enough to warp the orbits of celestial bodies, disrupting planetary systems and potentially ejecting planets, including habitable ones, into the freezing depths of interstellar space. This scenario raises an alarming question: could our own galaxy be at risk of such an event? While the chances of a rogue black hole directly colliding with the Milky Way are incredibly low, the presence of these objects in the universe suggests that at some point in cosmic history, galaxies may have been irreversibly reshaped by their influence. But the mysteries don't end there. Some scientists speculate that chaotic triple black hole systems might hold the key to understanding one of the most baffling questions in physics: what happens to information that falls into a black hole? According to classical physics, when matter crosses the event horizon of a black hole, it is lost forever. But quantum mechanics suggests that information cannot simply vanish, it must be preserved in some way, even if we don't yet understand how. This paradox, known as the black hole information problem, has puzzled physicists for decades. Some theories propose that information is somehow encoded on the event horizon itself, while others suggest that black holes slowly leak information back into the universe over vast time scales through a process called Hawking radiation. In the case of chaotic triple black hole systems, the extreme gravitational interactions could create scenarios where matter repeatedly enters and exits the gravitational influence of different black holes before being permanently consumed. This could mean that some information is preserved longer than expected or even escapes in unexpected ways. If so, these systems might provide a natural testbed for exploring whether black holes truly destroy information or merely transform it in ways we have yet to comprehend. Some researchers believe that studying the interactions of chaotic black hole systems could lead to groundbreaking discoveries about the fundamental nature of reality itself. Adding another layer of complexity is the potential connection between chaotic triple black hole systems and dark matter. Dark matter remains one of the most mysterious substances in the universe. It neither emits nor absorbs light, making it invisible to traditional telescopes. We only know it exists because of its gravitational effects on galaxies, causing them to rotate faster than they should based on their visible mass. But what if some portion of what we call dark matter is actually made up of unseen, wandering black holes? If rogue black holes are more common than we realize, they could account for at least part of the missing mass that astronomers have long struggled to explain. This idea is particularly compelling given recent discoveries suggesting that black holes might be far more numerous than previously thought. Some studies propose that small, primordial black holes, formed in the earliest moments of the universe, could be scattered throughout space, acting as a hidden population of gravitationally active objects that contribute to the overall mass of galaxies without ever revealing themselves through light emissions. If chaotic triple black hole interactions are a mechanism for creating more rogue black holes, then they might be playing a far more significant role in shaping the structure of the universe than we currently understand. Perhaps the most mind-bending possibility of all is that chaotic triple black hole systems could be revealing something deeper about the very nature of space-time. Some speculative theories suggest that these systems might create distortions so extreme that they allow for temporary shortcuts through space, akin to naturally occurring wormholes. While wormholes remain purely theoretical, the idea that extreme gravitational interactions could open pathways to other regions of the universe, or even other universes, has fascinated physicists for years. If chaotic black hole systems are capable of momentarily linking distant parts of space, then they might explain some of the strange, unexplained cosmic signals that astronomers have detected. Fast radio bursts, FRBs, for example, are incredibly powerful but short-lived bursts of radio waves that appear to originate from deep space. While some have been linked to magnetars, highly magnetic neutron stars, others remain unexplained. Could these bursts be caused by energy released when black holes in a chaotic system briefly form a temporary connection through space-time? Some researchers believe this is at least worth considering, especially given that some FRBs appear to repeat in ways that don't fit neatly with known astrophysical processes. Additionally, chaotic triple black hole systems might be responsible for some of the most extreme gravitational waves ever detected. Gravitational waves are ripples in spacetime caused by the acceleration of massive objects, first predicted by Einstein and confirmed through direct observation in 2015. Most of the gravitational waves we've detected so far have come from binary black hole mergers. But if we could detect waves from triple black hole interactions, they might contain unique signatures that reveal new physics. Unlike simple, predictable waveforms produced by two black holes spiraling into each other, the waves from a chaotic three-body interaction would be much more complex and erratic, potentially carrying information about aspects of gravity that we have yet to uncover. As we continue to improve our ability to observe the universe, chaotic triple supermassive black hole systems remain among the most perplexing and fascinating mysteries in astrophysics. Their unpredictable gravitational interactions challenge our understanding of orbital mechanics. Their potential to create rogue black holes raises questions about the safety of galaxies, and their possible connections to dark matter and quantum information paradoxes suggest they may hold the key to some of the deepest secrets of the cosmos. What we do know for certain is that these systems exist and that their influence is vast. They are hidden within the hearts of distant galaxies, shaping the very fabric of space-time in ways we are only beginning to grasp. And yet, despite their terrifying power and complexity, they remain out of reach, silent, invisible giants conducting an endless, chaotic dance in the depths of space. The dance of chaotic triple supermassive black hole systems is more than just a fascinating astrophysical phenomenon. It's a direct window into the fundamental nature of gravity itself. Einstein's general theory of relativity describes gravity as the curvature of space-time caused by mass, and black holes are the ultimate test of this theory. They warp spacetime so severely that nothing, not even light, can escape their grasp. But what happens when not just two, but three supermassive black holes interact in an intricate gravitational battle? The equations governing their motion become nearly impossible to solve with classical methods. This is what physicists call the three-body problem, a problem so complex that, even with modern supercomputers, exact solutions remain elusive. Unlike binary systems, where gravitational waves can be relatively predictable as the two black holes spiral inward, triple black hole interactions add an extra layer of unpredictability. These systems can oscillate between moments of temporary stability and bursts of chaotic activity. The gravitational forces shift rapidly, sometimes pulling one black hole closer to the other two, sometimes ejecting one entirely from the system. And in the most extreme cases, two of the black holes might briefly merge, only to be torn apart again by the intense gravitational tug-of-war before they can fully coalesce. This kind of event could generate some of the most bizarre and distorted gravitational waves ever recorded, if we can learn how to detect them. That's the real challenge. While LIGO and Virgo have made groundbreaking discoveries in gravitational wave detection, their sensitivity is primarily tuned to detect relatively short-lived signals from binary mergers. But chaotic triple black hole systems may generate signals that are longer, more erratic, and harder to distinguish from background noise. This raises an intriguing possibility. Have we already recorded gravitational waves from these systems without realizing it? If so, the data could be buried within the vast amounts of information collected by gravitational wave observatories, waiting for new analytical techniques to uncover it. Another major mystery surrounding these systems is their role in galactic evolution. Most galaxies are believed to harbor a single supermassive black hole at their center. However, when galaxies merge, which is a common event in the history of the universe, their central black holes don't simply vanish. Instead, they slowly migrate toward one another, eventually forming a binary system. But what happens when a third black hole is introduced into this equation? This can occur if a third galaxy merges into the system before the first two black holes have had time to fully combine. In these scenarios, the presence of a third supermassive black hole disrupts the gradual merger process, causing the system to enter a chaotic state. Interestingly, this chaotic dynamic could explain certain peculiarities in the structure of some galaxies. For instance, some galaxies exhibit unusual, elongated cores where stars seem to be stretched out in ways that don't align with typical gravitational models. These features could be the result of gravitational disturbances caused by a triple black hole system. The immense gravitational forces exerted by these black holes could send shockwaves through the surrounding star fields, redistributing matter in ways that defy our conventional understanding of galactic formation. But perhaps one of the most tantalizing aspects of chaotic triple supermassive black hole systems is the possibility that they could be the source of some of the most powerful and mysterious cosmic events we have ever observed. Quasars, extremely bright galactic cores powered by supermassive black holes consuming vast amounts of matter, sometimes exhibit sudden, inexplicable changes in brightness. Some of these changes are too rapid to be explained by traditional accretion models, leading scientists to suspect that hidden within these bright cosmic beacons, multiple black holes may be engaged in a gravitational battle. If a chaotic triple system exists at the heart of a quasar, the shifting gravitational forces could cause massive fluctuations in the accretion disk, leading to the erratic brightening and dimming that astronomers struggle to explain. Beyond that, chaotic triple black hole systems could be responsible for the creation of some of the most extreme jets in the universe. Many supermassive black holes produce relativistic jets, high-energy streams of particles that shoot out from the poles of the black hole at nearly the speed of light. These jets are often aligned with the black hole's rotational axis, but in some galaxies, astronomers have observed jets that are misaligned, wobbly, or even appear to change direction over time. A chaotic triple system could provide an answer. As the gravitational tug-of-war between the black holes constantly shifts the orientation of the system, it could also be altering the direction of the jets, causing the bizarre, unpredictable behavior we see in some active galaxies. And then there's the possibility that chaotic triple black hole systems could be influencing the very expansion of the universe itself. One of the great mysteries in cosmology is why the universe's expansion appears to be accelerating. Dark energy is the leading explanation. But what if an unseen population of chaotic black hole systems is playing a role? If these systems are more common than we realize, their complex gravitational interactions could be subtly influencing the motion of galaxies on a cosmic scale. While this idea remains highly speculative, it's a reminder that we still have much to learn about the large-scale dynamics of the cosmos. Even more mind-bending is the idea that chaotic triple black hole systems could provide insight into the possibility of higher dimensions. Some physicists propose that our universe may have more than the 3 spatial dimensions we experience, and that gravity might be leaking into these extra dimensions in ways we haven't yet detected. If this is true, then the extreme gravitational interactions of triple black hole systems could serve as natural laboratories for studying these hidden dimensions. If the equations governing their motion show unexpected deviations from general relativity, it could be a sign that something beyond our current understanding is at play. With every new discovery, the mystery deepens. Triple supermassive black hole systems defy our attempts to predict their behavior, challenging our models of gravity, galaxy formation, and even the nature of space-time itself. They are hidden giants, locked in an eternal gravitational struggle, shaping the universe in ways we are only beginning to comprehend. And yet, despite their power and influence, they remain one of the least understood phenomena in astrophysics. The more we study them, the more questions arise. Are they more common than we think? Could one exist hidden within our own galaxy? Do they hold the key to unlocking the mysteries of dark matter, dark energy, or even the true nature of black holes? And most intriguingly of all, if we could one day learn to predict their behavior, would we uncover secrets about the universe that have eluded humanity for centuries? One thing is certain, the story of chaotic triple supermassive black hole systems is far from over. These enigmatic forces continue to warp space, shape galaxies, and push the limits of what we thought was possible. The deeper we look into the cosmos, the more we realize that the universe is not just stranger than we imagine, it's stranger than we can imagine. The sheer unpredictability of chaotic triple supermassive black hole systems challenges our very understanding of how the universe operates at its most extreme limits. Unlike binary black holes, which follow a relatively predictable path toward eventual merger, the dynamics of 3 competing gravitational titans push physics into the realm of pure chaos. When 3 massive bodies interact under the force of gravity, their motions can become so erratic that even the most powerful supercomputers struggle to simulate their behavior over long periods. This unpredictability, known as deterministic chaos, means that even the slightest difference in initial conditions can lead to vastly different outcomes, making it nearly impossible to predict the fate of any given system with absolute certainty. One of the most fascinating aspects of these chaotic systems is the process of black hole ejections. In some cases, the gravitational interactions become so intense that one black hole is violently expelled from the system at extraordinary speeds. These runaway black holes, sometimes referred to as hypervelocity black holes, can be flung out of their home galaxies entirely, doomed to wander the cosmos alone for eternity. Some scientists suspect that there could be countless rogue black holes drifting through intergalactic space, remnants of these chaotic triple interactions. These ejected black holes could carry with them remnants of their former accretion disks, or even entire clusters of stars that were gravitationally bound to them before they were launched away. But what happens to the remaining two black holes after one is ejected? The system doesn't simply settle into a stable binary configuration, at least, not immediately. The two remaining black holes may continue to interact chaotically for millions of years before eventually merging, or they could be disturbed again if another galaxy merger introduces yet another black hole into the equation. This suggests that many galaxies may go through repeated cycles of black hole mergers and disruptions, each event contributing to the evolution of the galaxy and the distribution of its stars. These chaotic systems could also play a crucial role in solving another cosmic mystery: the origin of supermassive black holes themselves. One of the biggest unsolved questions in astrophysics is how black holes grow to such enormous sizes so quickly in the early universe. Observations of ancient quasars, bright galactic centers powered by actively feeding supermassive black holes, suggest that some black holes reached billions of solar masses within just a few 100 million years after the Big Bang. Standard models of black hole growth struggle to explain this rapid accumulation of mass, but chaotic triple systems might offer a solution. If multiple black holes frequently interact and merge in the crowded environments of early galaxies, they could grow far more quickly than previously thought. This idea also ties into the concept of black hole hierarchies, where smaller black holes merge to form intermediate mass black holes, which in turn merge into supermassive ones. Chaotic triple systems could be key players in this hierarchical growth, facilitating frequent and rapid mergers that accelerate the black hole formation process. If this is the case, then our current models of black hole evolution might need significant revisions, incorporating the role of chaotic interactions in shaping the cosmic landscape. Another intriguing consequence of these systems is their potential impact on the fabric of spacetime itself. General relativity predicts that the extreme warping of spacetime caused by massive objects in motion should generate gravitational waves, ripples that propagate outward at the speed of light. The detection of gravitational waves from binary black hole mergers has already revolutionized astrophysics, but chaotic triple systems could produce an entirely new class of gravitational wave signals. Instead of the smooth, predictable waveforms seen in binary mergers, these chaotic systems could generate erratic, fluctuating signals that are far harder to detect. Some researchers have speculated that detecting these irregular gravitational waves could unlock new insights into the fundamental nature of gravity. If the signals deviate from what general relativity predicts, it could indicate the presence of new physics, perhaps even hints of quantum gravity, the long-sought theory that would unify Einstein's relativity with the strange world of quantum mechanics. This makes chaotic triple supermassive black hole systems not just objects of curiosity, but potentially some of the most important laboratories for testing the deepest mysteries of the universe. There's also the question of what happens when these chaotic systems interact with the matter around them. The extreme gravitational forces at play can create violent tidal disruptions, where entire stars are shredded apart by the immense gravitational pull of the black holes. Some of the debris from these destroyed stars may form temporary accretion disks around the black holes, producing sudden bursts of energy that could be detectable as unusual flashes of X-rays or gamma rays. These flares could help astronomers identify hidden triple systems, as they may exhibit patterns of variability that don't match those of ordinary binary systems. But even more bizarre is the possibility that some of this disrupted matter could be ejected at relativistic speeds, forming high-energy outflows that blast through their surrounding galaxies. These cosmic outbursts could trigger massive shockwaves that influence star formation, either by compressing interstellar gas and triggering new star births or by heating and dispersing the gas, suppressing star formation entirely. This means that chaotic triple supermassive black holes might not just be shaping individual galaxies, they could be influencing the evolution of entire clusters of galaxies on a cosmic scale. Perhaps the most mind-boggling question of all is whether chaotic triple supermassive black hole systems could ever produce a scenario where a black hole escapes the gravitational pull of the universe itself. In theory, if a black hole were ejected from a triple system with enough velocity, it could reach speeds approaching the cosmic escape velocity, the speed required to break free from the gravitational influence of all surrounding matter. If this were to happen, the black hole would continue traveling outward indefinitely, never to return. This raises the wild possibility that there could be black holes launched billions of years ago that are still hurtling through space at unimaginable speeds, destined to drift forever into the cosmic abyss. With so many unanswered questions, it's clear that chaotic triple supermassive black hole systems represent one of the greatest astrophysical frontiers yet to be fully explored. As observational techniques improve, new telescopes like the upcoming Laser Interferometer Space Antenna, LISA, will be capable of detecting gravitational waves from these chaotic systems with unprecedented precision. With each new discovery, we may come closer to unraveling the hidden forces that shape the universe, uncovering secrets that challenge our very understanding of physics. And yet, despite everything we know, the ultimate fate of these systems remains shrouded in mystery. Do all chaotic triple systems eventually settle into stable binaries? Or do some remain locked in an endless cycle of gravitational chaos? Could they be more common than we think, lurking undetected in the hearts of distant galaxies? And most intriguingly of all, what would happen if our own galaxy, the Milky Way, were one day to find itself home to such a system? The mysteries of space are vast, and chaotic triple supermassive black hole systems are among the most perplexing of them all. As our understanding of the cosmos deepens, these gravitational titans will continue to challenge our perceptions of reality, pushing the boundaries of what we know and revealing just how little we truly understand about the workings of the universe. The possibility that chaotic triple supermassive black hole systems could exist in more galaxies than we currently suspect raises profound questions about the nature of galactic evolution. If these systems are common, it means that galaxies are not just shaped by slow, steady gravitational interactions over billions of years, but rather by violent, unpredictable events where supermassive black holes engage in high-stakes cosmic battles. This unpredictability could be a major factor in why some galaxies grow into enormous elliptical structures while others remain spiral-shaped. If a triple black hole system disrupts its host galaxy enough, it might even be responsible for completely reshaping the distribution of stars, gas, and dark matter, leading to radically different galactic structures. Consider the case of galaxies that appear to have unusually large central black holes compared to their overall mass. Traditionally, astronomers have assumed that supermassive black holes grow primarily by slowly accreting gas or through occasional mergers with other black holes. But what if some of the most extreme cases, where a black hole seems disproportionately massive relative to its host galaxy, are actually the result of chaotic triple systems? In such a scenario, one black hole could dominate the interactions, absorbing most of the mass while the others are ejected or disrupted. This could explain why some galaxies contain black holes that seem far too large to have grown through normal means. One of the most difficult challenges in studying these systems is the fact that supermassive black holes are, by their very nature, invisible. They do not emit light, and they can only be detected indirectly through their gravitational effects on surrounding matter. But chaotic triple systems provide a unique opportunity. Their extreme and erratic motions can leave signatures in the way their host galaxies behave. For example, if a supermassive black hole system is truly chaotic, it may produce unusual distortions in the motion of stars and gas within its host galaxy. Instead of moving in smooth, predictable orbits, the stars may exhibit strange, looping paths that defy conventional gravitational models. This is where advanced observational techniques come into play. Astronomers are now using cutting-edge instruments like the Event Horizon Telescope, EHT, and extremely sensitive gravitational wave detectors to hunt for signs of these chaotic interactions. In the future, next-generation space telescopes could allow us to directly observe the gravitational influence of triple black hole systems, providing a clearer picture of how often these interactions occur. One of the most tantalizing possibilities is that some of the brightest and most energetic objects in the universe, quasars, may actually be powered by chaotic triple supermassive black hole systems. Quasars are among the most extreme objects in the cosmos, emitting more light than entire galaxies due to the immense gravitational forces at play around their central black holes. But some quasars exhibit irregular variability, with their brightness fluctuating in ways that don't match the typical behavior of a single feeding black hole. Could it be that some of these fluctuations are the result of three black holes locked in an unpredictable gravitational dance, each periodically disrupting the flow of matter around the others? If this is the case, then understanding chaotic triple systems could completely reshape our understanding of how quasars operate. Instead of viewing them as single black holes steadily consuming matter, we might need to rethink them as dynamic, ever-changing systems where multiple black holes are in constant motion, alternately feeding on and disrupting their surroundings. Another area where chaotic triple supermassive black holes could have profound consequences is in our understanding of dark matter. While dark matter remains one of the greatest mysteries in physics, some theories suggest that its distribution could be influenced by the behavior of supermassive black holes. If triple black hole interactions are more common than previously thought, they could help explain some of the strange distributions of dark matter observed in galaxies. For example, certain galaxies appear to have large voids in their dark matter halos, regions where dark matter is unexpectedly sparse. One possibility is that chaotic black hole interactions eject large amounts of matter, both normal and dark, into intergalactic space. This would mean that black holes don't just shape the visible structures of galaxies. They could also be responsible for sculpting the unseen framework of dark matter that underlies the entire universe. And then there's the question of what happens when a chaotic triple system reaches its endgame. The most common outcome is that two of the black holes eventually merge, while the third is flung away. But what if, under rare circumstances, all three black holes merge simultaneously? Such an event would release an almost unimaginable amount of gravitational energy, producing the most powerful gravitational waves ever detected. These waves could provide crucial new insights into the fundamental nature of gravity itself, potentially revealing whether Einstein's theory of general relativity remains accurate under the most extreme conditions imaginable. This raises another fascinating possibility: the existence of black holes with masses far beyond anything currently observed. If triple black hole systems do occasionally undergo simultaneous mergers, the resulting black hole could be orders of magnitude larger than anything we have ever detected. These ultramassive black holes, potentially weighing in at hundreds of billions of solar masses, could lurk in the hearts of the most ancient and massive galaxies, hidden from view but exerting an immense gravitational influence on their surroundings. And what about our own galaxy, the Milky Way? Could it one day become the site of such a chaotic system? Current observations suggest that our galaxy's central supermassive black hole, Sagittarius A*, is relatively isolated. However, in a few billion years, the Milky Way is expected to collide with its neighboring galaxy, Andromeda. This cosmic collision will bring together not just two galaxies, but also their respective supermassive black holes. If a third black hole, perhaps from a smaller satellite galaxy, joins the mix, our own galaxy could become home to a chaotic triple system. What would this mean for the future of the Milky Way? In the long term, it could lead to the ejection of one of the black holes, altering the galaxy's structure in ways we can't yet predict. Alternatively, if a merger occurs, it could trigger a burst of energetic activity, transforming the Milky Way's core into a powerful quasar for a period of time. While such events are billions of years away, they highlight just how interconnected the fate of galaxies and their central black holes truly are. Ultimately, chaotic triple supermassive black hole systems represent one of the most extreme and enigmatic frontiers of modern astrophysics. They challenge our understanding of gravity, galactic evolution, and even the nature of space-time itself. As technology advances and our ability to observe these systems improves, we may finally begin to unravel their secrets. But for now, they remain one of the greatest cosmic mysteries, reminders that, no matter how much we think we know about the universe, there is always more waiting to be discovered. The implications of chaotic triple supermassive black hole systems stretch far beyond just their immediate surroundings. They may be one of the primary drivers of large-scale cosmic evolution, influencing the structure of entire clusters of galaxies. When galaxies collide, their black holes often play the decisive role in determining the final outcome. If a triple black hole system forms in the aftermath of a galactic merger, its chaotic interactions could send gravitational shockwaves throughout the cluster, potentially disrupting other galaxies in its vicinity. This means that the impact of these systems isn't limited to individual galaxies. They could be shaping the universe on a scale we've only just begun to comprehend. One of the most intriguing aspects of chaotic triple black hole systems is their potential role in gravitational wave astronomy. While we've already detected gravitational waves from binary black hole mergers, a triple system introduces an entirely new set of complexities. Instead of a predictable chirp, the signal produced by a binary merger, gravitational waves from a chaotic triple system would be erratic, producing bursts of energy at unpredictable intervals. Detecting such a signal would be like trying to decipher the chaotic movements of three dancers on a dark stage, each moving according to their own rhythm yet still influencing one another. If we could detect these signals, they would provide unparalleled insight into the nature of black holes and gravity itself. Some theoretical models suggest that under extreme conditions, the chaotic interactions of three supermassive black holes could even produce gravitational waves strong enough to warp spacetime on a cosmic scale. This could have profound implications for our understanding of the universe, potentially offering clues about the fundamental nature of dark energy, the mysterious force driving the expansion of the cosmos. But perhaps the most mind-bending possibility is that these chaotic interactions might open the door to entirely new physics. General relativity has been remarkably successful in explaining the behavior of black holes, but we know that at extreme scales, especially in the presence of multiple interacting singularities, it starts to break down. Some physicists speculate that chaotic triple black hole systems might reveal previously unknown aspects of quantum gravity, the long-sought theory that would unify general relativity with quantum mechanics. In this sense, studying these systems could be the key to answering some of the deepest questions in theoretical physics. Beyond the theoretical implications, there's also the question of just how many of these systems might exist. Current observational techniques are not yet refined enough to detect them directly, but indirect evidence suggests they may be more common than previously thought. In recent years, astronomers have discovered several galaxies with oddly behaving central black holes, objects that appear to be moving in ways that don't quite match the predictions for a single, isolated supermassive black hole. Some of these anomalies might be explained by the presence of an unseen third black hole, locked in a chaotic gravitational struggle with the others. Future space-based gravitational wave detectors, such as the upcoming Laser Interferometer Space Antenna, LISA, could provide the first definitive proof of these systems. Unlike current detectors, which are designed to pick up the relatively high-frequency waves produced by stellar mass black hole mergers, LISA will be tuned to detect the much lower frequency signals associated with supermassive black holes. If chaotic triple systems are common, LISA may pick up their signatures scattered across the universe, revealing just how widespread these cosmic battles really are. But even without direct detection, the influence of these systems may already be visible in the strange structures of certain galaxies. Some galaxies exhibit double or triple nuclei, regions where multiple dense clusters of stars seem to exist at the center. While these could be remnants of past mergers, they could also be the visible markers of ongoing triple black hole interactions. If this is the case, it means that chaotic triple systems aren't just a theoretical curiosity. They're actively shaping the galaxies we see around us. One particularly tantalizing case is that of galaxies with so-called recoiling black holes. In these systems, a supermassive black hole appears to have been violently ejected from the center of its host galaxy, moving at speeds of thousands of kilometers per second. While some of these ejections could be the result of binary black hole mergers, others might be the final outcome of a chaotic triple interaction, where one black hole gets flung out while the remaining two merge. If we can confirm this mechanism, it would mean that some of the most extreme events in the universe, black holes being launched out of galaxies like slingshot projectiles, are actually the result of these unpredictable gravitational encounters. The possibility that our own galaxy could one day host such a system adds an extra layer of intrigue. When the Milky Way and Andromeda collide in about 4 billion years, their central black holes will likely begin a long and complex dance of interaction. If a third black hole joins the mix, perhaps from another smaller galaxy caught in the collision, the result could be a chaotic triple system right in our cosmic backyard. Such a scenario could have dramatic consequences for the future of the Milky Way. If one of the black holes is ejected, it could carry away a significant portion of the galaxy's central mass, potentially altering the structure of our galaxy forever. If a merger occurs instead, it could trigger a burst of radiation powerful enough to turn the center of the Milky Way into an active quasar, flooding the surrounding regions with intense energy. In either case, the event would be one of the most dramatic in the galaxy's history, reshaping its structure and possibly influencing the formation of future stars and planetary systems. Ultimately, chaotic triple supermassive black hole systems remain one of the most mysterious and compelling frontiers in astrophysics. They challenge our understanding of how black holes behave, how galaxies evolve, and even the nature of spacetime itself. As our observational tools improve and our theoretical models become more refined, we may soon unlock the secrets of these cosmic juggernauts. But for now, they stand as some of the most enigmatic and awe-inspiring phenomena in the known universe. A reminder that, even in an age of rapid scientific discovery, the cosmos still holds mysteries beyond our wildest imagination. The existence of chaotic triple supermassive black hole systems raises profound questions about the ultimate fate of galaxies. If these systems are common, then many galaxies may undergo extreme transformations due to the interactions of their central black holes. When two black holes merge in a relatively straightforward binary system, the result is a larger, more massive singularity that eventually settles into a stable state. But in a triple system, stability is rarely an option. The complex gravitational tug-of-war between three enormous singularities leads to unpredictable outcomes. Some black holes may merge, others may be ejected at tremendous speeds, and the remaining ones may be left oscillating in chaotic orbits for millions of years. One of the most fascinating possibilities is that these systems could explain the origins of some of the most energetic phenomena in the universe. Take quasars, for example. These are the intensely bright, active galactic nuclei powered by supermassive black holes consuming vast amounts of material. While we know that binary mergers can trigger quasar activity by feeding gas into the central black hole, a triple system introduces an additional level of instability. The erratic gravitational interactions could force vast clouds of gas and dust into the accretion disks of the black holes, dramatically increasing their brightness and energy output. Some of the most powerful quasars we've observed might be the result of chaotic triple interactions, where multiple black holes are stirring up their surroundings, creating a spectacle visible across billions of light-years. Another possibility is that these systems play a role in shaping the mysterious class of objects known as ultraluminous X-ray sources, ULXs. These are sources of X-ray radiation so intense that they seem to defy our understanding of how black holes behave. Some theories suggest that ULXs could be intermediate-mass black holes accreting matter at an extreme rate. But another explanation is that they could be the remnants of past triple black hole interactions. If a chaotic system results in one black hole being violently ejected while another remains behind, the remaining black hole could end up in a position where it rapidly consumes material in an unusually energetic way. This could explain why some ULXs appear to be more active than typical stellar mass black holes but not quite as massive as the supermassive ones at the centers of galaxies. There's also the question of whether chaotic triple systems could be responsible for some of the most dramatic and mysterious cosmic explosions. Gamma-ray bursts, GRBs, the most powerful explosions in the universe, typically come from the collapse of massive stars or the mergers of neutron stars. However, there's a subclass of GRBs, known as long-duration GRBs, that last longer than expected and don't always fit neatly into these categories. Some researchers speculate that these explosions might be caused by the violent interactions of multiple black holes in a chaotic system, particularly if one black hole is flung into a dense region of gas, triggering an immense release of energy. If this is the case, then chaotic triple black hole systems could be responsible for some of the most energetic events we've ever observed. But perhaps the most mind-bending possibility is that these systems could provide evidence for entirely new physics. Right now, our understanding of gravity is based on general relativity, which has been incredibly successful in explaining how black holes behave. But general relativity is not a complete theory. It breaks down in extreme environments, such as the interiors of black holes or the moments just after the Big Bang. Some physicists believe that chaotic triple black hole interactions might provide a testing ground for new theories of gravity. The complex, unpredictable nature of these systems means they could be generating gravitational effects that we don't yet understand, possibly revealing deeper truths about the fundamental nature of space-time. One intriguing idea is that the chaotic motion of three supermassive black holes could warp spacetime so intensely that it creates temporary distortions, regions where the very fabric of reality is twisted in ways we don't normally see. Some speculative theories even suggest that under the right conditions, such extreme interactions could lead to the formation of temporary wormholes or other exotic structures in spacetime. While this remains purely theoretical, it's an idea worth exploring, especially as our ability to detect and study these systems improves. Astronomers are already working on ways to detect these chaotic triple systems more effectively. One promising approach is through long-term monitoring of galactic centers using powerful telescopes like the James Webb Space Telescope and the upcoming Extremely Large Telescope, ELT. These instruments will allow us to track the movement of black holes with unprecedented precision, helping us identify systems where multiple black holes are interacting. In addition, improvements in gravitational wave detection, such as the planned Laser Interferometer Space Antenna, LISA, could allow us to hear the chaotic dance of triple black hole systems in deep space. If LISA picks up irregular, unpredictable gravitational wave signals that don't match the patterns of binary black hole mergers, it could be our first direct evidence of a chaotic triple system in action. Interestingly, some recent observations suggest that we might have already found a few of these systems without realizing it. In 2020, astronomers discovered a galaxy known as SDSS J0849+1114, which appeared to contain three actively feeding supermassive black holes. The black holes were separated by just a few thousand light-years, an incredibly short distance on a cosmic scale, which strongly suggested that they were interacting gravitationally. If this system is indeed a chaotic triple, studying it could provide invaluable insights into how these systems evolve and what role they play in shaping galaxies. Another potential candidate is the galaxy NGC 6240, which has long been known to host two supermassive black holes at its core. However, some researchers believe there may be a third, hidden black hole in the mix, making it one of the closest known triple systems. If this is the case, then we might be witnessing a chaotic triple interaction happening in real time, right in our cosmic neighborhood. The more we learn about these systems, the more we realize just how much they could be influencing the universe. They may be responsible for shaping galaxies, fueling quasars, producing extreme gravitational waves, and even challenging our understanding of physics itself. And yet, we've barely scratched the surface of what's out there. There could be thousands, perhaps even millions, of these chaotic triple systems scattered throughout the cosmos, hidden among the countless galaxies we've yet to fully explore. As technology advances, our ability to detect and study these systems will only improve. Future telescopes and gravitational wave observatories will allow us to peer deeper into the universe than ever before, revealing the hidden chaos at the hearts of galaxies. Each new discovery will bring us closer to understanding the true nature of these enigmatic cosmic titans. But for now, chaotic triple supermassive black hole systems remain one of the most mysterious and awe-inspiring phenomena in astrophysics. They challenge our understanding of gravity, test the limits of our observational capabilities, and hint at the presence of new, undiscovered forces shaping the cosmos. And as we continue to explore the vast expanse of space, one thing is certain: the universe still holds secrets that are beyond our wildest imagination. The chaotic nature of triple supermassive black hole systems doesn't just shape galaxies. It may also be responsible for some of the most extreme cosmic events ever witnessed. Consider what happens when three supermassive black holes, each millions or even billions of times the mass of the Sun, are locked in a gravitational struggle. Unlike binary systems, which follow relatively predictable orbits before merging, triple systems are fundamentally unstable. The constant gravitational interactions create a highly erratic, ever-changing environment where anything can happen. Sometimes two of the black holes merge while the third is flung away at astonishing speeds. Other times, all three remain locked in an unpredictable dance for millions of years, each exerting an immense pull on the others, warping space-time in ways we are only beginning to understand. One of the most dramatic consequences of these chaotic interactions is the phenomenon of hypervelocity black holes, supermassive black holes that are ejected from their host galaxies at speeds of thousands of kilometers per second. While hypervelocity stars have been observed before, stars flung out of their galaxies by the gravitational pull of black holes, the concept of hypervelocity black holes is far more extreme. If one black hole in a triple system gets caught in a particularly violent interaction, it can be catapulted out of its galaxy entirely, becoming a rogue black hole drifting through intergalactic space. Imagine a black hole billions of times the mass of the Sun hurtling through the void, completely untethered from any galaxy, carrying with it whatever matter it had accumulated. Such objects would be nearly impossible to detect, yet they might be lurking throughout the cosmos, invisible until they pass through a region dense enough to provide them with a new supply of gas to consume. If a hypervelocity black hole were to pass through a distant galaxy, it could trigger a burst of quasar-like activity, illuminating the surrounding space in a sudden, violent display of energy. Some of the most mysterious and unexplained flashes of radiation observed by astronomers might, in fact, be the signatures of these runaway black holes. Even when they don't get ejected, chaotic triple black hole systems are responsible for some of the most intense gravitational forces in the universe. These forces don't just shape the fate of galaxies, they actively distort space and time itself. General relativity predicts that when massive objects accelerate, they produce ripples in space-time known as gravitational waves. We've detected gravitational waves from binary black hole mergers, but triple black hole systems introduce a whole new level of complexity. Instead of the smooth, predictable signals of a two-body merger, a triple system produces an erratic, chaotic wave pattern that constantly shifts in frequency and intensity. Current gravitational wave observatories, like LIGO and Virgo, are designed to detect relatively short bursts of waves from merging black holes. However, the chaotic interactions of triple black holes produce a different kind of signal, one that persists for much longer periods, possibly even millions of years. This is where the next generation of gravitational wave detectors, such as the upcoming Laser Interferometer Space Antenna, LISA, will be crucial. Unlike ground-based detectors, LISA will operate in space, allowing it to detect the low-frequency gravitational waves produced by the complex motion of supermassive black holes. If we start picking up gravitational waves that show signs of erratic, three-body interactions, it could be our first direct confirmation that these chaotic systems exist in large numbers. Beyond their impact on galaxies, quasars, and gravitational waves, chaotic triple black hole systems might also play a role in one of the most perplexing mysteries of modern astrophysics: the apparent existence of intermediate mass black holes. We know that stellar mass black holes, formed from the collapse of massive stars, typically range from a few times the mass of the Sun to a few dozen solar masses. On the other end of the scale, we have supermassive black holes, which can be millions or billions of times the mass of the Sun. But in between, there's a gap, a missing population of black holes in the range of a few thousand to 100,000 solar masses. One possible explanation is that chaotic triple interactions could be responsible for creating intermediate mass black holes. When three supermassive black holes interact, the sheer energy involved can lead to extreme outcomes. If one black hole is ejected while the other two merge, the resulting object might not be as massive as either of the originals, but it could fall into that elusive middle range. If these intermediate mass black holes are then ejected into intergalactic space, they would be incredibly difficult to detect, potentially explaining why they seem so rare. This raises another intriguing possibility. What if some of these ejected black holes are still wandering through space, waiting to be discovered? There could be hundreds, thousands, or even millions of rogue black holes drifting between galaxies, completely invisible to us until they interact with matter. If a rogue intermediate mass black hole were to pass close to a star or a dense cloud of gas, it could briefly become visible, emitting bursts of radiation as it feeds. Some astronomers believe that unexplained flashes of X-ray and gamma-ray radiation seen in deep space might be caused by these wandering black holes suddenly consuming material they encounter. But perhaps the most unsettling idea is that chaotic triple black hole systems could one day pose a direct threat to life as we know it. Right now, the supermassive black hole at the center of the Milky Way, Sagittarius A*, is relatively calm. It's not consuming much material, and our solar system is in no immediate danger. But what if, in the distant future, the Milky Way collides with another galaxy that also contains a supermassive black hole? This is not just speculation. Astronomers already know that the Milky Way and the Andromeda Galaxy are on a collision course. In a few billion years, they will merge, and their central black holes will begin interacting. If a third black hole is introduced into the mix, perhaps from a smaller galaxy caught in the collision, the result could be a chaotic triple system right in our own galactic backyard. If that happens, there's no telling what the consequences could be. The gravitational chaos of a triple system could send shockwaves through the galactic core, disrupting star formation, altering the orbits of planets, and possibly even triggering the ejection of black holes. In the absolute worst-case scenario, a supermassive black hole could be flung in our direction, though the odds of that happening are incredibly slim. Still, the idea that our galaxy could one day play host to a chaotic triple black hole system is a reminder of just how unpredictable the universe can be. Despite how much we've learned about black holes, chaotic triple systems remain one of the biggest unanswered questions in astrophysics. Are they rare, or are they lurking in galaxies all around us? How often do they eject black holes into deep space? And could these ejected objects explain some of the most mysterious cosmic events we've observed? And perhaps most intriguingly, could these systems be hiding new laws of physics that we have yet to uncover? For now, the universe keeps its secrets well. But with every new discovery, we inch closer to understanding the true nature of these cosmic behemoths. The more we study black holes, the more we realize that they are not just passive voids in space. They are engines of destruction, chaos, and transformation, shaping the universe in ways we are only beginning to grasp. And as our technology improves, we may one day find ourselves face to face with the triple system in action, witnessing the ultimate dance of destruction on a scale beyond human comprehension. Chaotic triple supermassive black hole systems may be among the most extreme and unpredictable phenomena in the universe, but their implications go far beyond individual galaxies. They challenge the very way we understand gravity, space-time, and the evolution of the cosmos. One of the most intriguing aspects of these systems is their ability to push the boundaries of physics, particularly when it comes to general relativity and even the possibility of new physics beyond Einstein's equations. The warping of spacetime in a triple black hole system is not just severe, it's erratic, fluctuating in ways that may expose weaknesses in our current theories. General relativity does an excellent job of predicting how two massive objects interact, but once a third object is introduced, the calculations become vastly more complex. This is known as the three-body problem, one of the longest-standing mysteries in physics. Unlike two objects that orbit predictably around each other, three massive bodies create a system that is inherently chaotic, meaning that small changes in initial conditions can lead to wildly different outcomes. In other words, even if we had a perfect mathematical description of a triple black hole system, its long-term behavior would be impossible to predict. This chaotic nature makes these systems one of the best places to test the limits of general relativity. If we were able to closely observe a triple black hole system in real time, measuring not just gravitational waves but also how light bends around them, and how they interact with surrounding matter, we might start seeing anomalies that don't fit Einstein's equations. Some physicists speculate that such systems could be natural laboratories for quantum gravity, the elusive theory that unifies general relativity with quantum mechanics. Right now, gravity is the only fundamental force of nature that does not have a quantum description, and black holes represent a major roadblock in our understanding. When matter is pulled into a black hole, all information about it is seemingly lost, which contradicts the principles of quantum mechanics. This is known as the black hole information paradox, and it's one of the greatest unsolved problems in physics. Triple supermassive black hole systems could provide a way to study these paradoxes in action. If gravitational waves from these systems show unexpected patterns, perhaps fluctuations that hint at hidden layers of physics, we may finally get a clue about how gravity behaves at its most extreme. Some radical theories even suggest that triple black hole interactions could briefly expose what lies inside an event horizon. In conventional physics, nothing can escape from within a black hole's event horizon, but under extreme gravitational conditions, some models predict that information or even radiation might be able to leak out in unpredictable ways. If future observations reveal gravitational wave signals that don't match our expectations, it could be the first sign that something deeper is at play. Beyond their implications for physics, chaotic triple black hole systems may also hold the key to solving one of the greatest mysteries of cosmic evolution: how supermassive black holes grow so fast. We know that shortly after the Big Bang, galaxies already contain massive black holes at their centers. But given the amount of time it should take for a black hole to grow through accretion, by slowly consuming matter, many of these early giants shouldn't exist. One possibility is that instead of growing gradually, some supermassive black holes were formed by rapid mergers in chaotic triple systems. If three massive black holes came together in the early universe, their interactions could have accelerated the merging process, allowing them to reach enormous sizes much faster than standard models predict. The discovery of triple black hole systems in distant galaxies may provide evidence for this theory. Some astronomers believe that the most luminous quasars, galaxies with incredibly bright centers powered by active supermassive black holes, could be the result of triple interactions. When three black holes collide, they release an unimaginable amount of energy, briefly outshining the entire host galaxy. These bursts of radiation could explain some of the most extreme and short-lived cosmic events we've observed, including mysterious gamma-ray bursts that don't fit the typical patterns of black hole mergers. As we continue to explore the universe, triple black hole systems will likely remain one of the most mysterious and unpredictable phenomena we encounter. Their chaotic nature means that no two systems are alike. Each one is a unique battlefield of gravitational forces, playing out a cosmic dance that could last millions of years or end in an instant with a violent merger. Whether they hold the key to new physics, the origins of supermassive black holes, or the fate of entire galaxies, one thing is certain: understanding them is one of the greatest challenges in astrophysics. And perhaps the biggest mystery of all is how many of these systems exist right now, hidden in the depths of space, waiting to be discovered. The mind-bending nature of chaotic triple supermassive black hole systems raises another profound question: what happens when these immense gravitational monsters finally collide? A binary black hole merger alone is one of the most violent events in the universe, releasing energy in the form of gravitational waves powerful enough to ripple through the very fabric of space-time. But when three supermassive black holes are involved, the complexity and sheer magnitude of these interactions escalate to unimaginable levels. The gravitational waves they produce wouldn't just be stronger, they would be fundamentally different, carrying intricate patterns that might reveal hidden aspects of gravity itself. Scientists suspect that in such a system, the merger process doesn't happen smoothly. Instead, one black hole may be violently ejected from the system before the remaining two collide. This is due to what's called the gravitational slingshot effect. Essentially, when three massive objects interact, their chaotic gravitational tug-of-war can accelerate one of them to extraordinary speeds, launching it away from the others at millions of kilometers per hour. This could lead to the existence of rogue supermassive black holes, massive, invisible giants hurtling through space without a home galaxy. Some astronomers have even proposed that we may have already detected evidence of such runaway black holes in the form of unexplained cosmic jets and faint but fast-moving radio sources. If a black hole is ejected from a chaotic triple system, it carries with it an entire disk of material, a swirling vortex of superheated gas and debris that was once feeding into its event horizon. This means that as it speeds away from its former companions, it continues shining brightly, behaving much like a quasar but without a central galaxy to anchor it. Such rogue quasars could be detectable, offering a rare glimpse into what happens when gravitational battles go completely off the rails. Even more fascinating is what happens to the remaining two black holes once one is ejected. Unlike standard binary black holes, which orbit each other in relatively predictable ways, the survivors of a chaotic triple system may have wildly eccentric orbits, stretched and distorted to extremes by their past interactions. This means that when they finally merge, they could produce an entirely new type of gravitational wave signal, one that differs significantly from the waves detected from ordinary binary mergers. Scientists are on the lookout for such signals, as they could provide key evidence that chaotic triple systems are far more common than we currently believe. One of the most bizarre implications of these systems is the possibility of something called a recoiling black hole. In certain conditions, when two black holes merge after a chaotic interaction, the newly formed black hole can receive a powerful gravitational kick, sending it rocketing through space at incredible speeds. If the kick is strong enough, it can escape its home galaxy entirely, becoming yet another rogue supermassive black hole adrift in the cosmos. Some of the strongest gravitational kicks ever calculated suggest that such a black hole could be moving at thousands of kilometers per second, fast enough to travel from one side of the Milky Way to the other in just a few million years. But the mysteries don't stop there. Some physicists have speculated that the intense, chaotic conditions inside a triple black hole system might create effects that push beyond known physics. For instance, in the moments leading up to a merger, space-time itself becomes so warped and turbulent that strange things could happen, such as brief violations of classical physics, where quantum effects might become important on a cosmic scale. In this extreme gravitational environment, some models predict that black holes could momentarily leak information or that new forms of exotic matter could emerge. These are just hypotheses for now, but they hint at the possibility that chaotic triple black hole systems might not just be objects of study in astrophysics. They could be gateways to entirely new realms of science. And what about time itself? We already know that black holes warp time due to their immense gravity. But in a system where three black holes are locked in a chaotic, ever-changing dance, time distortion could become even more bizarre. If an observer were caught within the gravitational field of such a system, they might experience time passing at vastly different rates depending on their position relative to the black holes. This could lead to strange effects where time appears to slow down, speed up, or even loop in unpredictable ways. Could chaotic black hole systems create natural time dilation zones so extreme that they allow glimpses into the deep past of the universe? While this remains speculation, it's an area of active interest for physicists studying general relativity and the nature of time itself. Perhaps the most mind-blowing possibility of all is the idea that chaotic triple supermassive black hole systems might be linked to the creation of new universes. Some cosmologists have proposed that the singularity inside a black hole, the point where all known physics breaks down, could be connected to the birth of a new universe, effectively making black holes seeds of new realities. If this is true, then triple black hole mergers could be triggering the formation of entirely new cosmic domains, hidden beyond the event horizons we can never see past. This leads us to a tantalizing question. Is it possible that our own universe was born from the remains of a chaotic black hole system in another reality? If the singularities inside black holes really do act as gateways to new universes, then every time a triple black hole system collapses, it could be giving birth to a new cosmos, each with its own laws of physics, its own galaxies, and perhaps even its own forms of life. As wild as this idea sounds, some versions of string theory and loop quantum gravity suggest that such a process could be possible. If future observations reveal patterns in gravitational waves that hint at unexpected structures or hidden dimensions, it could be the first sign that chaotic black hole systems are doing far more than just distorting space. They might be shaping the fundamental structure of reality itself. And so, the mystery deepens. How many chaotic triple supermassive black hole systems are out there right now, unseen and unsuspected, playing out cosmic dramas that stretch across billions of years. How many of them are sending rogue black holes on journeys across the universe? How many are warping time and space in ways we have yet to imagine? And could one of them, somewhere in the vastness of the cosmos, be the birthplace of something entirely new? The answers are out there, waiting in the darkness. The idea that chaotic triple supermassive black hole systems might serve as cosmic engines for the birth of new realities isn't just a wild hypothetical. It ties into some of the deepest questions about the nature of existence itself. If black holes are connected to the formation of new universes, then what we observe in these chaotic systems might be the closest thing we have to witnessing the process of cosmic genesis in action. But to truly understand this, we need to dive even deeper into the physics of these monstrous gravitational entities and explore what happens at the very edge of our scientific understanding. One of the most baffling aspects of black holes, especially in a system where three of them are in a violent gravitational dance, is the concept of information paradox. According to standard physics, information, meaning the fundamental details about the particles and energy that make up matter, should never be destroyed. Yet, when matter falls into a black hole, it seemingly vanishes beyond the event horizon, lost forever. This contradiction has puzzled physicists for decades. But in a chaotic triple system, where black holes are not just absorbing matter but also flinging it around at near-light speeds, the paradox becomes even more complex. Some theories suggest that in such an environment, information might not be lost but instead scrambled and redistributed across space-time in ways we don't yet understand. This ties into another mind-bending concept, the holographic principle. Some scientists believe that the universe itself might function like a giant hologram, where all the information about a three-dimensional space is actually encoded on a two-dimensional surface. If this is true, then chaotic triple black hole systems could provide a test bed for this theory. The gravitational interactions between the black holes might stretch, distort, and imprint information onto the fabric of spacetime in a way that reveals the fundamental nature of reality. Could the swirling chaos of these systems be the key to proving that the universe is, at its core, a holographic projection of deeper physics? But the mysteries don't end there. Another strange phenomenon associated with black holes is the concept of wormholes, hypothetical bridges through spacetime that could connect distant parts of the universe or even different universes entirely. While no direct evidence of wormholes has been found, some theories suggest that the intense gravitational interactions in a chaotic triple black hole system might create the right conditions for them to form. If such a system were to momentarily stabilize, the immense warping of spacetime could theoretically allow a shortcut through the cosmos. Now, imagine for a moment that somewhere in the universe, there exists a triple supermassive black hole system that is not just chaotic, but precisely aligned in such a way that it creates a natural wormhole. If this were the case, it could serve as a gateway to another part of the universe, or even to another reality entirely. Could an advanced civilization, if one exists somewhere out there, have discovered such a system and used it as a means of intergalactic travel? It's purely speculation, but the idea is fascinating, a cosmic highway hidden within the depths of black hole chaos, waiting to be unlocked. Another strange and lesser-known consequence of chaotic black hole interactions is the possibility of ultra-energetic particle acceleration. In a typical black hole system, the intense gravitational pull creates a massive accretion disk, a swirling inferno of gas, dust, and even entire stars being torn apart and consumed. But in a triple black hole system, the warping effects become far more extreme. As the black holes shift positions and interact, they can create what is known as relativistic jets, colossal beams of high-energy particles that are ejected at nearly the speed of light. These jets are already some of the most powerful phenomena in the universe, but in a chaotic triple system, the process could supercharge them beyond anything we've observed before. Some scientists speculate that these systems might be responsible for the most extreme cosmic rays, high-energy particles that occasionally bombard Earth, carrying far more energy than anything we can produce in particle accelerators. If we could trace the origins of these ultra-energetic particles back to a triple black hole system, it might give us direct insight into the physics happening at the edge of known reality. But here's where things get even weirder. If a triple black hole system can accelerate particles to such extreme speeds, it might also create conditions where exotic particles, ones that don't normally exist in our observable universe, could briefly appear. Some speculative theories suggest that chaotic black hole interactions could temporarily create regions of space where the laws of physics, as we know them, break down. In such an environment, particles that normally wouldn't exist might flicker into reality, potentially giving us clues about hidden aspects of the universe, such as extra dimensions or undiscovered forces of nature. And speaking of breaking physics, let's talk about something even more speculative. Could chaotic triple black hole systems be responsible for unexplained cosmic anomalies? Over the years, astronomers have detected strange phenomena that don't quite fit with our current understanding of the universe. Some of these include unusually strong bursts of radiation, unexplained shifts in the trajectories of distant celestial objects, and even bizarre signals that seem to defy known physics. While many of these mysteries remain unsolved, some researchers have begun to wonder if chaotic black hole interactions might be playing a role. For instance, what if some of the strange, high-energy bursts we've observed in deep space aren't coming from exploding stars, but instead from the final, cataclysmic moments of a triple black hole merger? What if some of the unexplained gravitational anomalies we've measured in galaxies are actually caused by the hidden presence of a chaotic black hole system warping spacetime in ways we haven't accounted for? And then there's the possibility that these systems could be responsible for some of the oddest signals we've ever detected, fast radio bursts, FRBs. These are ultra-short, intense pulses of radio waves that seem to come from all over the universe, but their exact origins remain unknown. Some theories suggest they might be linked to neutron stars or magnetars, but others speculate that they could be connected to extreme gravitational events, such as black holes merging or interacting in unpredictable ways. Could chaotic triple black hole systems be a hidden source of these enigmatic bursts? If so, studying them might help us unlock one of the biggest cosmic mysteries of our time. But let's take a step back and ask an even bigger question: how many of these systems are actually out there? If chaotic triple black hole systems are as common as some simulations suggest, then they might be playing a far larger role in shaping the universe than we ever imagined. They could be influencing the formation of galaxies, acting as gravitational sculptors that determine where stars and planetary systems form. They might even be affecting the large-scale structure of the universe itself, creating vast cosmic webs of matter and energy that define the shape of everything we see. And what if, hidden within one of these systems, lies something even stranger, something we haven't even thought to look for yet? Could these chaotic black hole interactions create rare, temporary states of matter? Could they generate gravitational effects so extreme that they momentarily expose hidden aspects of space-time? Could they be responsible for anomalies that have puzzled astronomers for decades? The more we learn about chaotic triple supermassive black hole systems, the more questions arise. But perhaps the most exciting part is that we're just beginning to scratch the surface. As new telescopes and gravitational wave detectors come online, we may soon have the ability to directly observe these systems in action, peeling back the layers of mystery that surround them. And when we do, who knows what we'll find? One thing is certain: the universe is far more chaotic, unpredictable, and awe-inspiring than we ever imagined. And at the heart of that chaos, triple supermassive black hole systems may hold secrets that could change our understanding of reality itself. The idea that chaotic triple supermassive black hole systems might hold secrets about the fundamental nature of reality is not just an abstract thought experiment. It's a frontier of modern astrophysics that challenges everything we think we know about gravity, space, and time. When three black holes of immense mass get locked into a complex gravitational dance, the sheer unpredictability of their interactions creates a natural laboratory for some of the most extreme physics in the universe. But what happens when this chaos reaches its breaking point? Could such systems be responsible for some of the most bizarre, unexplained phenomena we've ever observed? One of the biggest questions surrounding chaotic black hole systems is what happens in their final moments. When two black holes merge, we detect massive bursts of gravitational waves, ripples in spacetime that carry away energy and momentum. But in a triple system, things are far more complicated. The interaction between the three black holes creates an ever-changing gravitational field, which means that instead of a smooth, predictable merger, you get a violent, erratic series of near collisions, slingshots, and disruptions. This creates what some scientists call gravitational chaos, a situation where the final fate of the system could go in multiple unpredictable directions. One possible outcome is that two of the black holes eventually merge, but the third one is violently ejected from the system. This process, known as a gravitational recoil, could send a black hole hurtling through the universe at thousands of kilometers per second. If this happens, it could mean that rogue supermassive black holes are wandering the cosmos, invisible and undetectable except for their gravitational effects on nearby matter. Some astronomers have even proposed that certain unexplained movements of stars in distant galaxies might be caused by these runaway black holes. If true, then chaotic triple systems aren't just cosmic anomalies. They might be actively reshaping galaxies in ways we've never realized. But there's another, even stranger possibility. Some theories suggest that when three black holes interact in this extreme way, they might temporarily form what's known as a gravitationally bound resonance state. This is a situation where the black holes don't immediately merge or get ejected, but instead enter a period of intense, high-energy interaction where they distort spacetime so severely that they create effects we've never seen before. Some physicists speculate that these interactions could momentarily produce exotic structures in spacetime, such as microscopic wormholes, closed time-like curves, which could theoretically allow time travel, or even temporary zones where quantum effects dominate over classical gravity. This leads to another fascinating question. Could chaotic triple black hole systems be a natural source of unexplained cosmic anomalies? Over the years, astronomers have detected strange signals and odd gravitational effects that don't quite fit into our current understanding of the universe. Some of these include unexplained shifts in the motion of celestial objects, mysterious flashes of energy, and even signals that seem to defy the known laws of physics. While many of these anomalies are still unexplained, some scientists believe that highly dynamic black hole systems could be responsible. For example, what if some of the high-energy gamma-ray bursts we've detected aren't coming from the collapse of massive stars, but instead from the final moments of a triple black hole interaction? In a system where three black holes are twisting and distorting each other's accretion disks, you could get powerful bursts of energy that rival those produced by supernovae. These bursts might look like ordinary gamma-ray bursts at first, but on closer examination, they could reveal signatures of intense gravitational interactions that have never been seen before. And then there's the question of fast radio bursts, FRBs, the mysterious, ultra-brief flashes of radio waves that have puzzled scientists for years. Some FRBs repeat, while others seem to be one-time events, and their exact origin remains unknown. Could a chaotic triple black hole system be responsible for some of these signals? If two black holes briefly interact and then one gets ejected, the sudden shift in gravitational forces could produce a shockwave that momentarily amplifies electromagnetic radiation, creating an FRB-like signal. If we could identify a chaotic black hole system as the source of one of these bursts, it would completely change our understanding of how these signals are produced. But perhaps the most mind-bending possibility is that chaotic triple supermassive black hole systems might be gateways to something even stranger. If space-time is being stretched, distorted, and twisted to extreme degrees in these systems, could they momentarily create conditions that allow us to glimpse beyond our own universe? Some speculative theories in quantum gravity suggest that certain types of extreme gravitational environments could temporarily expose hidden dimensions or even create bridges between different regions of spacetime. If this were true, then chaotic black hole systems might be among the only places in the universe where we could directly observe evidence of physics beyond the known four dimensions of space and time. Of course, this remains purely hypothetical for now, but it raises an intriguing thought. What if some of the unexplained cosmic phenomena we've observed, such as bursts of energy that appear and disappear without a clear source, are actually glimpses of deeper structures hidden within the chaos of black hole interactions? Could we be unknowingly detecting evidence of hidden physics, but simply not recognizing it because we don't yet have the right theoretical framework? The more we learn about chaotic triple supermassive black hole systems, the more questions arise. But one thing is becoming clear: these systems are far more than just cosmic curiosities. They could be among the most powerful and mysterious engines of change in the universe, shaping galaxies, generating extreme gravitational effects, and possibly even hinting at deeper aspects of reality itself. And as we continue to refine our observational tools, using gravitational wave detectors, radio telescopes, and space-based observatories, we may soon unlock even more secrets hidden within these chaotic cosmic maelstrom. When that happens, we might not just be answering questions about black holes. We might be uncovering entirely new aspects of the universe that we never even imagined. The deeper we go into the mysteries of chaotic triple supermassive black hole systems, the more we begin to see them not just as astronomical oddities, but as natural experiments in extreme physics. Every known law of nature is pushed to its absolute limit in these systems, from the warping of space-time to the release of unimaginable amounts of energy. The unpredictability of their behavior challenges even our most advanced simulations, and yet, they may hold answers to some of the biggest questions in physics. Questions that go beyond black holes themselves and into the very fabric of reality. One of the biggest unresolved mysteries in modern astrophysics is what happens when space-time itself becomes so distorted that it can no longer behave in a stable, predictable manner. In normal conditions, general relativity provides a remarkably accurate description of how gravity works, from the orbits of planets to the bending of light around massive objects. But in a chaotic triple black hole system, we enter a regime where space-time is no longer smooth and continuous. Instead, it becomes a turbulent, ever-shifting landscape where traditional laws start to break down. This leads to a fascinating possibility. Could chaotic black hole systems be a natural testing ground for quantum gravity? Right now, one of the biggest problems in physics is the fact that general relativity, which describes gravity, and quantum mechanics, which describes the behavior of particles on the smallest scales, don't seem to work together. In most situations, this isn't an issue. General relativity governs the large-scale structure of the universe, while quantum mechanics controls the tiny world of atoms and subatomic particles. But near black holes, and especially in chaotic systems with extreme gravitational interactions, these two realms collide. Some physicists believe that the key to understanding quantum gravity might lie in observing black hole mergers and their chaotic interactions. In a normal black hole merger, gravitational waves are emitted in a predictable pattern that can be modeled using Einstein's equations. But in a system with three black holes interacting chaotically, the gravitational waves they produce might contain unexpected distortions, subtle deviations from what general relativity predicts. If we could detect these anomalies, they might provide our first experimental clues about how gravity behaves at the quantum level. This is where the future of astrophysics gets exciting. Right now, we have gravitational wave observatories like LIGO and Virgo, which have already detected black hole mergers and confirmed many of Einstein's predictions. But these detectors are only the beginning. Next-generation observatories, such as the planned LISA, Laser Interferometer Space Antenna, will be capable of detecting much lower-frequency gravitational waves, the kind that would be produced by supermassive black hole interactions. If chaotic triple black hole systems really do generate unexpected gravitational effects, LISA might be the key to uncovering them. But what about the observational challenges? One of the reasons chaotic black hole systems are so difficult to study is that they are incredibly rare. While binary black holes, two black holes orbiting each other, are relatively common in the universe, triple systems are much harder to find. This is because, over long periods of time, most triple black hole systems don't remain stable. Either one of the black holes is ejected, or two of them merge and leave behind a simpler binary system. However, astronomers have recently begun to identify candidates for these chaotic systems. Some active galactic nuclei, AGNs, which are the bright, energetic centers of galaxies, show signs of unusual movement in their emission lines, patterns in the light they give off that suggest complex gravitational interactions. Some of these could be caused by triple black holes in chaotic motion, creating a constantly shifting gravitational environment that distorts the material around them. In some cases, We might even be able to observe the direct effects of a black hole ejection. If a triple system goes through a phase of instability, and one of the black holes gets flung away at high speed, it could carry with it a trailing stream of gas and stars. This kind of event, known as a hypervelocity black hole, would be an extraordinary discovery, as it would allow us to study the effects of black hole motion outside of a galaxy. If we could pinpoint such an object, it would provide direct evidence that chaotic triple systems not only exist, but actively reshape the structure of galaxies. There's also the question of what happens to the remaining black holes after such an ejection. When one black hole is kicked out of a system, the remaining two experience a sudden shift in their gravitational balance. This could lead to an increased rate of accretion, where surrounding matter is rapidly pulled in, heating up and producing powerful emissions of X-rays and other high-energy radiation. Some unusual X-ray bursts observed in deep space might actually be the aftershocks of a triple black hole system entering its final, chaotic stages. And then there's the strangest possibility of all. What if chaotic black hole systems occasionally create conditions where exotic physics takes place? Some physicists have speculated that in certain extreme gravitational environments, temporary violations of classical physics might occur. This could include brief fluctuations where energy conservation momentarily breaks down, or where the usual rules of cause and effect become distorted. Could some of the unexplained cosmic signals we've detected over the years be the result of such anomalies? One particularly strange phenomenon that some scientists have considered is the idea that chaotic black hole interactions might briefly create conditions similar to the Big Bang. If space-time is stretched and compressed in just the right way, could it create a tiny, self-contained bubble of expanding space? While this remains purely speculative, it raises the mind-boggling possibility that some chaotic black hole systems might not just be destroying matter, they could, under the right conditions, be seeding the formation of new universes. Of course, this idea is highly controversial, and we are far from having any direct evidence for it. But even if chaotic black hole systems don't create new universes, they remain one of the most extreme and mysterious phenomena in the cosmos. And as our ability to observe them improves, they may provide the missing pieces to some of the biggest unanswered questions in physics. What we do know for sure is that chaotic triple supermassive black hole systems are not just theoretical curiosities. They are real, and they have the power to warp spacetime, generate gravitational waves, and even reshape galaxies. The more we study them, the more we realize just how much we still don't understand about the fundamental nature of gravity and the universe itself. And with every new observation, every new signal detected, we might be one step closer to uncovering secrets that have been hidden in the fabric of spacetime for billions of years. The deeper we dive into the mysteries of chaotic triple supermassive black hole systems, the more we realize how much they challenge our current understanding of the universe. Every fundamental law we think we know is tested to its absolute limit in these systems. Gravity, time, space, energy. Everything we take for granted becomes unpredictable in the presence of three enormous black holes locked in a cosmic dance of destruction. But here's where things get even stranger. What if these chaotic systems don't just distort space and time, but also affect reality itself on a fundamental level? Could these be natural laboratories for some of the strangest, most mind-bending phenomena in physics? Let's start with the concept of space-time turbulence. We normally think of space as a smooth, continuous fabric that bends in the presence of mass, like a stretched-out rubber sheet. This is how general relativity describes gravity. Objects with mass create dips in the fabric of spacetime, and other objects move along those dips. But what happens when those dips become so extreme that they start interfering with each other chaotically? That's exactly what occurs in a system with three supermassive black holes. Unlike binary systems, where two black holes orbit each other in a relatively predictable way, triple systems introduce a level of chaos that even our best simulations struggle to handle. The gravitational pull of each black hole constantly shifts, creating a turbulent mess where space itself ripples and warps unpredictably. Instead of smooth curves, we get violent distortions, twists and folds in spacetime that change on a cosmic timescale. In a sense, these systems act like gigantic gravitational storms, where the very shape of the universe around them is in constant flux. Now, consider what this means for time itself. In normal circumstances, time flows at different rates depending on gravity. The stronger the gravity, the slower time moves. Near a black hole, time slows down dramatically due to the immense gravitational pull. But in a chaotic triple system, time dilation becomes erratic. Depending on where you are, time might slow down, speed up, or even shift in unexpected ways. If an observer were somehow caught in the gravitational field of such a system, without being torn apart, of course, they might experience reality in a way completely different from anything we can imagine. But here's where things get truly bizarre. Some physicists have speculated that in certain extreme gravitational environments, like those found in chaotic black hole systems, time might momentarily behave in a way that breaks our traditional understanding of cause and effect. Normally, we expect events to happen in a logical sequence, first a cause, then an effect. But what if, in the tangled mess of space-time surrounding these black holes, that sequence became scrambled? Could we see effects that happen before their causes? Could information travel in ways that seem impossible from our perspective? This might sound like pure science fiction, but some theoretical models suggest that under the right conditions, closed time-like curves, paths in spacetime that loop back on themselves, could exist near black holes. In a chaotic triple system, where gravity is constantly shifting in unpredictable ways, the likelihood of such loops forming might be higher than anywhere else in the universe. If these loops exist, they could theoretically allow for scenarios where an event causes itself, leading to some of the strangest paradoxes imaginable. Of course, this remains highly speculative. But even if we don't go that far, there's still the very real possibility that chaotic black hole systems might create entirely new states of matter and energy. One of the biggest mysteries in physics is dark matter, the invisible substance that makes up most of the universe's mass. We still don't know what dark matter is made of, but some researchers have proposed that it could be linked to extreme gravitational environments. Could chaotic black hole systems somehow generate or interact with dark matter in ways we don't yet understand? Similarly, there's dark energy, the mysterious force that is accelerating the expansion of the universe. If chaotic black hole interactions involve energy being released in unexpected ways, could they be tied to the behavior of dark energy? Could they serve as cosmic engines that influence the large-scale structure of the universe in ways we haven't yet realized? And what about quantum effects? One of the strangest ideas in modern physics is the concept of quantum foam. The idea that, on the smallest scales, space itself isn't smooth but instead constantly fluctuating. These fluctuations normally occur at scales far smaller than anything we can directly observe. But what if, in the extreme gravitational conditions of a chaotic black hole system, these fluctuations were amplified to a level where they could influence the macroscopic world? This leads us to another wild possibility. Could chaotic black hole systems act as natural portals between different regions of spacetime? Wormholes, hypothetical tunnels through space, are often thought of as purely theoretical constructs. But if they do exist, they would likely form in areas where spacetime is highly curved and unstable. If any place in the universe could naturally generate a wormhole, it would be a chaotic system with three massive black holes warping spacetime in unpredictable ways. If such a wormhole were to form, where would it lead? Could it connect different parts of the universe? Or could it even serve as a gateway to another reality? This is where our current understanding of physics reaches its limits. While we don't have evidence of such structures existing, the idea that chaotic black hole interactions could create conditions where new physics emerges is not entirely out of the question. Beyond the theoretical, there are real-world observations that continue to puzzle astronomers. Some of the most energetic and unusual cosmic events, such as fast radio bursts, FRBs, and ultra-high-energy cosmic rays, have no clear explanation. Could chaotic black hole systems be responsible for some of these mysterious phenomena? If a triple black hole system goes through a phase of extreme instability, the energy released could be unlike anything we've seen before. Some researchers have even speculated that certain unexplained signals from deep space might originate from these interactions. This also ties into the possibility that chaotic black hole systems could be responsible for some of the strangest anomalies in astrophysics. For example, astronomers have occasionally detected objects moving through space at speeds that seem impossible based on our current models. Some hypervelocity stars moving at extraordinary speeds, could be the result of interactions within triple black hole systems, where one star gets flung away while the remaining black holes settle into a new configuration. And then there's the idea that chaotic black hole interactions might serve as natural generators of exotic particles. In high-energy physics, when particles collide at extreme speeds, like in the Large Hadron Collider, they can create entirely new forms of matter. Could the extreme conditions near chaotic black hole systems do the same thing on a cosmic scale? Could they produce particles that don't normally exist anywhere else in the universe? If so, studying these systems might give us insights into physics beyond the standard model, revealing new forces or interactions we've never seen before. At this point, it's clear that chaotic triple supermassive black hole systems are not just rare cosmic curiosities. They are extreme laboratories where the universe pushes itself to its limits, where the laws of physics bend and twist in ways we don't fully understand. Whether they hold the key to solving the mysteries of dark matter, dark energy, or even the nature of time itself, one thing is certain: they are some of the most fascinating and mysterious objects in the cosmos. And the more we learn about them, the more we realize just how much we still don't know. The more we explore chaotic triple supermassive black hole systems, the more we realize they could be among the most powerful, destructive, and enigmatic structures in the cosmos. They challenge every known law of physics, warp space-time in unimaginable ways, and may even serve as cosmic engines for some of the most unexplained events in astrophysics. But there's another, even deeper layer to this mystery, one that brings us to the edge of what's possible in theoretical physics and cosmology. Let's take a moment to consider the idea of information loss in black holes. According to classical physics, anything that falls into a black hole is lost forever, crushed into the singularity where all matter and energy are reduced to an infinitely small point. However, quantum mechanics suggests that information can never truly be destroyed. This contradiction, known as the black hole information paradox, has been one of the biggest unresolved problems in physics for decades. Now, imagine this problem scaled up to a chaotic triple supermassive black hole system. Each of these black holes is constantly distorting space-time, pulling in matter, merging, and ejecting vast amounts of energy. If even a single black hole already poses an unsolvable paradox regarding information loss, what happens when three of them are interacting chaotically? Could information somehow escape in ways we don't yet understand? Could the violent interactions between these black holes create conditions where information is preserved, or even transferred to another part of the universe? This brings us to another mind-bending idea: holography. Some physicists believe that the entire universe might function like a hologram, where all the information about what happens in three-dimensional space is actually encoded on a two-dimensional surface at the edge of the universe. Black holes play a crucial role in this theory because their event horizons act as boundaries where information could be stored. But in a chaotic triple system, where event horizons constantly shift and merge, the implications of holography become even stranger. Could the interactions between these black holes encode information in a way that defies our current understanding? If that's the case, then chaotic black hole systems might not just be sites of destruction, they could be cosmic archives, places where the history of the universe is stored in ways we haven't yet deciphered. Some physicists have even speculated that black holes could function like natural quantum computers, processing information in ways beyond human comprehension. If this is true, then a triple black hole system could be one of the most complex computing structures in existence, operating on principles that go far beyond anything we can currently build. Now, let's push this idea even further. What if chaotic triple black hole systems are not just distorting space and time, but actively influencing the structure of the universe on a fundamental level? In cosmology, there's a concept called the cosmic web, the large-scale structure of the universe, where galaxies and clusters of galaxies are connected by vast filaments of dark matter. The gravitational pull of supermassive black holes plays a major role in shaping this structure. But in a system with three supermassive black holes locked in chaotic motion, could their gravitational influence be strong enough to distort the cosmic web itself? This could have enormous implications for how galaxies form, move, and evolve over billions of years. It might even explain some of the biggest mysteries in astrophysics, such as why certain galaxies move in ways that don't align with our current models of dark matter. If chaotic black hole systems exert gravitational forces that extend far beyond their immediate surroundings, they might be responsible for shaping entire regions of the universe in ways we don't yet understand. And then, there's the question of whether chaotic black hole systems could serve as natural mechanisms for universe-scale recycling. In some theoretical models, black holes don't just consume matter, they also release it back into the universe in highly energetic jets. These jets, composed of particles accelerated to nearly the speed of light, can travel for thousands or even millions of light years, influencing star formation and galactic evolution. In a chaotic system with three supermassive black holes, these jets could be far more complex, constantly shifting in direction and intensity. Could these systems be responsible for distributing the raw materials needed for new stars and planets to form? Could they be the engines driving the life cycle of the cosmos itself? And here's where things take a truly mind-blowing turn. Some physicists believe that black holes might not just be objects within our universe. They could be gateways to entirely new universes. This idea is based on the concept of white holes, the theoretical opposites of black holes. While black holes pull matter in, white holes would theoretically expel matter out, never allowing anything to enter. Some speculative models suggest that every black hole in our universe could be connected to a white hole in another universe, effectively making black holes into cosmic tunnels between different realities. If this is true, then a chaotic triple black hole system could be an intersection point between multiple universes, a place where space-time itself is so distorted that it creates bridges to other realities. Could these systems be responsible for some of the strange, unexplained anomalies we see in deep space? Could they explain why certain objects in the universe behave in ways that don't seem to fit within our current understanding of physics? Even more provocatively, some have speculated that if these chaotic systems do act as gateways, they might provide a mechanism for information or even matter to travel between universes. Could chaotic triple black hole systems be responsible for phenomena like gamma-ray bursts, the most powerful explosions in the universe, by channeling energy from another reality into ours? Could they serve as cosmic windows, where energy and matter from entirely different realms occasionally leak into our universe? These questions push the boundaries of what we can currently observe or test. But the mere fact that chaotic triple supermassive black hole systems exist forces us to rethink everything we know about the universe. They are some of the most extreme environments ever discovered, places where the very fabric of reality is constantly being rewritten. The more we study them, the more we realize that they might hold the answers to some of the biggest mysteries in physics, from the nature of dark matter and dark energy to the very origins of the cosmos itself. And perhaps, just perhaps, they might even be the key to understanding our own place in the universe. The deeper we dive into the mysteries of chaotic triple supermassive black hole systems, the more we begin to question the very nature of reality itself. These systems are not just chaotic in a simple, disorderly sense. Their gravitational interactions, space-time distortions, and energy emissions are operating on a level so extreme that they may hold answers to some of the greatest cosmic questions we have yet to solve. And the implications of their existence stretch far beyond what we can currently measure, perhaps even beyond the boundaries of our own universe. Let's consider another mind-boggling aspect of these chaotic systems: time itself. Time, as we understand it, is not an absolute force but rather something that is affected by gravity. The stronger the gravitational pull, the slower time moves relative to an outside observer. This has been experimentally confirmed in our own solar system. Clocks placed closer to Earth's surface run slightly slower than those placed at higher altitudes due to differences in gravitational influence. Now, take that same concept and amplify it by an almost unimaginable degree inside a chaotic triple black hole system. Each black hole in the system is warping time in its vicinity. But because these black holes are not stationary and are instead locked in a never-ending gravitational dance, the effects on time are constantly shifting. Imagine what this would mean for anything caught in their grasp. A star or a cloud of gas might experience time moving at a completely different rate depending on its position relative to the black holes. In some regions, time might slow to a crawl, while in others, it could speed up dramatically. Could this explain some of the strange, seemingly unexplainable events that astronomers have observed in deep space? Could some of the light signals we receive from distant galaxies be distorted because they pass through one of these chaotic systems and experience time dilation in ways we don't yet understand? Even more fascinating is the possibility that such systems could act as natural laboratories for testing theories about the ultimate fate of time itself. Some physicists believe that at the extreme edges of the universe, time might behave in ways that defy our current understanding. Chaotic triple black hole systems, with their constantly shifting gravitational fields, could provide us with the closest approximation to these extreme conditions. By studying them, we might gain insights into whether time is truly linear or if it might loop, fracture, or even cease to exist in certain conditions. This brings us to another profound question. Could these systems provide a key to understanding the true nature of gravity? Gravity remains one of the least understood fundamental forces in physics. Unlike electromagnetism, which we can manipulate and harness for technology, gravity remains stubbornly mysterious. We know that it bends space-time, that it governs the motion of celestial bodies, and that it affects time itself, but we still don't fully understand how it works on a quantum level. Chaotic triple black hole systems are among the most extreme gravitational environments in existence. The sheer complexity of their interactions could give us new insights into how gravity behaves in its most extreme form. Some scientists have even proposed that by studying the precise motion of these black holes, we might find discrepancies that could hint at new physics, perhaps even a unification of quantum mechanics and general relativity, something that has eluded physicists for over a century. One particularly exciting possibility is that these systems might produce gravitational waves with properties we've never observed before. Gravitational waves, ripples in space-time caused by massive objects accelerating, were first detected in 2015, confirming a major prediction of Einstein's general relativity. But so far, the gravitational waves we've observed have come from relatively simple events, such as binary black hole mergers. A chaotic triple system, with its constantly shifting gravitational field, could generate waves of such complexity and intensity that they might reveal entirely new aspects of how gravity works. Some physicists even speculate that gravitational waves from these systems could act as cosmic messengers, carrying information about conditions deep within the black holes themselves. If we could decode these signals, we might finally be able to peer past the event horizon and learn what truly happens inside a black hole, something that has remained one of the biggest unsolved mysteries in physics. But what if these chaotic black hole systems are not just cosmic anomalies? What if they play a fundamental role in the universe's evolution? Some theories suggest that black holes are essential for galaxy formation, acting as anchors around which stars and planets coalesce. If this is true, then triple black hole systems could represent an advanced stage in a galaxy's life cycle, perhaps even serving as catalysts for the next phase of cosmic evolution. In this scenario, chaotic triple black hole systems might not just be places of destruction, but also of creation. Their immense gravitational forces could stir up gas clouds, triggering star formation on an unprecedented scale. Their high-energy jets could enrich the surrounding space with heavy elements, providing the raw materials needed for new planets to form. And their interactions could shape the orbits of entire galaxies, influencing the structure of the universe itself. And then there's the possibility that these systems are not just influencing space and time within our universe, but could actually be gateways to something beyond. Some of the most speculative theories in modern physics propose that black holes could be connected to other regions of the cosmos through wormholes, hypothetical tunnels in spacetime that could, in theory, allow for faster-than-light travel or even connections between different universes. If such wormholes do exist, chaotic triple black hole systems might be the most likely places to find them. The extreme gravitational forces at play could stretch and twist spacetime in ways that make the formation of wormholes more likely. And if any advanced civilization were capable of harnessing such phenomena, these black hole systems could be natural locations for interstellar or even interdimensional travel. Could this explain some of the strange, high-energy cosmic signals we've detected from deep space? Signals that don't seem to match any known astrophysical process? Could some of these chaotic black hole systems be acting as natural accelerators, sending energy and information across the universe in ways we don't yet understand? The truth is, we are only just beginning to scratch the surface of what these systems might be capable of. Every new discovery raises more questions than it answers, pushing the boundaries of what we thought was possible. The more we learn, the more we realize that chaotic triple supermassive black hole systems are not just rare curiosities. They may hold the key to some of the biggest mysteries in the cosmos. And perhaps, just perhaps, by studying them, we might one day unlock secrets that change everything we know about reality itself. The more we unravel about chaotic triple supermassive black hole systems, the more we realize that they could be the most powerful cosmic laboratories nature has ever created. Their gravity wells are so deep that light itself struggles to escape, yet their interactions produce some of the most energetic and dynamic phenomena in the universe. These systems may not just be anomalies but fundamental components in the grand design of the cosmos, perhaps even the mechanisms that determine the life cycle of galaxies. One of the most perplexing questions astronomers are trying to answer is how these triple black hole systems form in the first place. Black holes are typically found in pairs, often formed when two galaxies merge and their central supermassive black holes come together. But for a third black hole to join the mix, something even more complex must have happened. One possible scenario is a series of galactic mergers. Perhaps a smaller galaxy with its own central black hole merged with an already forming binary black hole system. The resulting gravitational chaos would be extreme, with each black hole influencing the others in unpredictable ways. Once formed, a chaotic triple black hole system becomes an unpredictable, ever-shifting battlefield of gravitational forces. Unlike a binary system, where the motion follows a relatively stable path, a triple system is fundamentally unstable. The forces acting upon each black hole are constantly changing, leading to wild shifts in acceleration, velocity, and orbital trajectories. The system becomes a high-stakes game of gravitational tug-of-war, where at any given moment, one black hole could be flung away while the remaining two settle into a new, temporary balance, until another interaction disrupts it again. This unpredictability raises a fascinating question. Could one of these chaotic black holes eventually be ejected from the system entirely? The answer is yes. In fact, this might be one of the most violent outcomes of these interactions. If a smaller black hole in the trio receives a sudden, intense gravitational kick from its larger companions, it could be accelerated to such high speeds that it escapes the system entirely. These rogue black holes, sometimes called hypervelocity black holes, could then travel through intergalactic space at speeds of millions of miles per hour, carrying with them remnants of the extreme gravitational encounters they endured. If a black hole were to be ejected from a chaotic triple system, it would leave behind a trail of destruction. The surrounding matter, accretion disks, stars, and even planetary systems, would be thrown into turmoil. Some of this matter might be captured by the remaining black holes, fueling massive outbursts of energy as it spirals inward and is consumed. Other material might be thrown clear, flung into deep space at relativistic speeds. This could explain some of the bizarre cosmic events astronomers have observed: enormous, sudden bursts of energy that don't seem to match traditional supernovae or gamma-ray bursts. And what about the ejected black hole itself? If it were traveling fast enough, it might never be captured by another galaxy, doomed to drift through intergalactic space indefinitely. This would mean there are likely countless rogue black holes wandering the universe, invisible except for the faint distortions they create as they pass through gravitational fields. Some scientists speculate that these wandering black holes could even explain certain anomalies in galactic rotation, where unseen mass appears to be influencing the motion of stars. But here's where things get even stranger. If a chaotic triple black hole system does not result in an ejection, it could eventually merge into a single, ultramassive black hole. This process would take millions or even billions of years, But when it finally happens, it would unleash an event of almost unimaginable power. The merging of three supermassive black holes would create gravitational waves on a scale never before detected, waves so strong they could ripple across the entire observable universe. Current gravitational wave detectors, like LIGO and Virgo, can pick up signals from binary black hole mergers, but chaotic triple mergers would be something else entirely. These events would produce not just a single burst of gravitational waves but a prolonged, complex pattern of distortions as the three black holes gradually spiral inward. If scientists could detect and analyze these waves, they might gain unprecedented insights into the nature of gravity itself, perhaps even uncovering evidence of hidden dimensions or new laws of physics that we have yet to comprehend. Even more intriguingly, some researchers believe that chaotic triple black hole systems could be natural engines for accelerating particles to extreme energies. The immense gravitational fields at play could create conditions similar to those inside a particle accelerator, but on a cosmic scale. This could help explain some of the most mysterious high-energy cosmic rays that have been detected hitting Earth, particles traveling at nearly the speed of light with no obvious source. Could they be the remnants of chaotic black hole interactions from billions of years ago, flung across the cosmos and finally reaching our planet? There's also the possibility that these systems could act as gateways to phenomena that challenge the very fabric of our understanding. Some physicists have speculated that in the most extreme gravitational environments, where space-time is being stretched and twisted in multiple directions simultaneously, entirely new forms of matter and energy might emerge. Could chaotic triple black hole systems be places where exotic, previously unknown physics takes place? Could they be natural laboratories for understanding quantum gravity or even testing hypotheses about the multiverse? Perhaps one of the most mind-bending implications of chaotic triple black hole systems is their potential to serve as cosmic time machines. We know that black holes can warp time due to their intense gravity, but in a system where three are constantly interacting, the distortions could be even more extreme. In theory, if a spacecraft were to navigate carefully through such a system, staying just outside the event horizons and using the gravitational interactions to slingshot around the black holes, it could experience time dilation effects far beyond anything previously imagined. What if such a system allowed for a form of time travel, where an object could enter and emerge at a different point in time relative to an outside observer? While this remains purely speculative, it aligns with some interpretations of general relativity that suggest highly curved spacetime could permit shortcuts through time. If this were possible, could advanced civilizations, assuming they exist, have already discovered and utilized such systems for purposes beyond our comprehension? The idea that chaotic triple black hole systems could serve as cosmic gateways to other places or times is the kind of concept that stretches the limits of scientific imagination. But history has shown us that many of the most groundbreaking discoveries started as ideas that seemed impossible. Not long ago, black holes themselves were considered purely theoretical, with many physicists doubting their actual existence. Now, we have images of them, gravitational wave detections, and growing evidence of their role in shaping the universe. So, what else might be hiding in these chaotic gravitational maelstrom? Could they hold the answers to the true nature of reality? Could they help us uncover whether the universe is finite or infinite? Could they be the missing link in unifying quantum mechanics with general relativity? What we do know is that chaotic triple supermassive black hole systems are among the most extreme environments in the universe, pushing the boundaries of what we thought was possible. They are violent, unpredictable, and beyond anything we can truly comprehend. Yet, with each new discovery, we inch closer to unlocking their secrets. And if history is any indication, the answers we find will likely lead to even deeper and more profound mysteries. If chaotic triple supermassive black hole systems are already rewriting our understanding of gravity and cosmic evolution, imagine what they could tell us about the origin and ultimate fate of the universe itself. These systems exist at the extreme edges of physics, where our current models start to break down. If we can fully understand their mechanics, we might finally be able to bridge the gap between Einstein's general relativity and quantum mechanics, a goal that has eluded physicists for decades. One of the most perplexing issues in physics is the nature of singularities. At the center of each black hole lies a point where density becomes infinite, and our equations cease to function. When two black holes merge, their singularities are thought to combine, but in a chaotic triple system, things could be much stranger. What happens when three singularities interact in ways that our math can't yet predict? Do they remain separate, constantly shifting in position due to the extreme gravitational forces? Or do they fuse into something even more bizarre, something that defies our current definitions of space and time? There's also the question of what happens when a chaotic system like this collapses. Some theorists speculate that under certain conditions, instead of merging into a single black hole, the system could undergo what's known as a gravitational bounce. This would mean that instead of collapsing into a final singularity, the system could enter a state where gravitational forces counteract the collapse, creating a stable yet bizarre structure that has never been observed before. This idea ties into another mind-blowing possibility. Could chaotic triple black hole systems be responsible for creating entirely new universes? Some versions of the multiverse theory suggest that extremely energetic gravitational interactions, like the ones found in these systems, could generate new pockets of space-time, effectively birthing new realities separate from our own. If this is true, then every chaotic black hole system in our universe might be a cosmic seed, planting the foundations for an entirely new cosmos. And if new universes are being created, what does that mean for the one we live in? Could our own universe have been born from the remnants of an ancient chaotic black hole system in a previous cosmic cycle? This leads to the concept of eternal cosmic rebirth, where universes are not singular, one-time events but part of an ongoing process that never truly ends. But let's bring things back to the here and now. Right now, as we speak, these chaotic triple supermassive black hole systems are out there, in the depths of space, warping reality in ways we barely understand. They are reshaping galaxies, sending out powerful gravitational waves, and possibly even launching rogue black holes on journeys across the universe. Each time we observe one, we are looking not just at an astronomical object but at a puzzle piece in the grand design of the cosmos. And maybe, just maybe, these chaotic systems aren't just random phenomena. Maybe they serve a purpose in the vast structure of the universe, playing a role in its ultimate destiny. The more we uncover about them, the more we realize how little we truly know. And that might just be the most exciting mystery of all. The implications of chaotic triple supermassive black hole systems stretch beyond just astrophysics and into the very nature of reality itself. If these cosmic giants truly have the power to warp spacetime in unpredictable ways, then they could be the key to unlocking some of the deepest mysteries about our universe's structure. Could they serve as natural gateways to parallel dimensions? Could they be responsible for strange anomalies we've observed but never fully explained, like ultra-high-energy cosmic rays or unexplained fast radio bursts? One of the strangest things about black holes is their apparent ability to delete information. According to classical physics, anything that falls into a black hole should be lost forever. But quantum mechanics suggests that information can never be truly destroyed. This paradox, known as the information loss problem, has baffled scientists for decades. If chaotic triple black hole systems exist, where three supermassive singularities are constantly interacting, twisting, and distorting space-time beyond recognition, could they provide a missing piece of the puzzle? Perhaps, in the tangled gravitational web of such systems, information isn't lost but instead scrambled, rearranged, or even transported elsewhere in the cosmos. This brings up another unsettling thought. What if chaotic triple black hole systems are responsible for some of the universe's greatest cosmic disappearances? Over the years, astronomers have noted that certain galaxies seem to be losing mass at an unusual rate. Stars that should still be visible appear to vanish, as if being erased from existence. Could some of these missing celestial bodies have been caught in the unpredictable chaos of a triple black hole system, torn apart, and hurled into the void at such extreme speeds that they are no longer detectable? Or worse, could they have been pulled into an unknown region of spacetime, one that defies our ability to observe and measure? Another bizarre possibility emerges when considering the immense gravitational interactions of such systems. Normally, when two black holes merge, they release an enormous burst of gravitational waves, ripples in the fabric of spacetime that travel across the universe. But in a chaotic triple system, these waves could be far more complex, interfering with each other in strange and unexpected ways. Some scientists believe that these interactions might even allow for the temporary formation of stable gravitational echoes, where space-time itself resonates like a bell, producing faint but measurable distortions long after the initial wave has passed. If this is true, then chaotic black hole systems could act as natural cosmic beacons, sending out mysterious signals that could potentially be detected and studied. And then there's the question of scale. We know that supermassive black holes exist at the centers of galaxies, and we know that some galaxies collide and merge over time. This means that chaotic triple black hole systems could be far more common than we currently realize. What if, instead of being rare anomalies, they are actually a fundamental stage in the life cycle of galaxies? Perhaps every major galaxy, including our own Milky Way, has gone through, or will go through, a period where it harbors not one, not two, but three supermassive black holes locked in an unpredictable gravitational dance. If that's the case, then the history of our universe might be even more chaotic than we ever imagined. The formation of galaxies, the movement of stars, the very structure of the cosmos itself, all of it could be shaped, in part, by the hidden influence of these extreme systems. And if they play such a critical role, then understanding them isn't just an academic exercise. It's a necessity. Because if we don't fully grasp how these systems work, we might not see the next one coming. What happens if the Milky Way, which already has a massive black hole at its center, were to one day merge with another galaxy that also harbors one or two massive black holes? Could our own solar system become trapped in the chaos, flung out into intergalactic space, or worse, consumed entirely? And here's the wildest part. Some scientists speculate that the chaotic nature of these systems might not just affect space, it might also influence time itself. If extreme gravitational forces can warp space-time, as Einstein's theory predicts, then inside a chaotic triple black hole system, time could be flowing in strange and unpredictable ways. Could these systems create naturally occurring time loops? Could they lead to regions of space where time slows down or speeds up dramatically? If so, what would happen to anything caught in their grip? The more we explore these questions, the clearer it becomes that chaotic triple black hole systems are more than just rare cosmic oddities. They might be one of the most powerful and enigmatic forces in the universe. And if we can learn to decipher their secrets, we might finally start to understand not just the universe as it is, but the universe as it could be. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.